Exactly. Here's the actual PDF document. I'll share a copy through your chat. Live stream text, right? There we go.
But I guess, you know, if culling
Here's
is
that.
what they want to do, I guess, you know, they're on the pathway to it.
Well, I've been digging into some other stuff too, and I noticed that they were warned right before COVID pandemic came out that the solar minimum and the cosmic rays cause autoimmune diseases, heart conditions, stuff like this, and that they wanted to, they furthered that to find out if there was, more to it. And there absolutely is a pattern with the Spanish flu, all these different. They're right on solar minimums, man. All these, the 100-year ago event, the 2008 to 10 SARS thingy. I mean, these were all during solar minimums, grand solar minimums, and the normal 11-year cycles. And you know what, dude? The signals is so significant, and it's right on the peak on every bit of it, that I think they already know this. And this is a way to make money off of that. The fact that this is something that we can't really stop, or, you know what I mean? And if you warn the public about it, they'll go kind of crazy and try to hide underground.
That's interesting. So how do you think that's connected?
Well, the solar minimums are weaken the Earth's magnetic field. The Earth's magnetic field protects us from these high energy protons, cosmic rays that come in, and when they come in contact with your DNA, they do fucking funny mutations, funny things to them. So they'll hit one of your exosomes, turn it into a different type of virus than we're used to having, or something, and cause mutations that end up, they literally did specifically on the bat viruses and stuff, and found the mutations could be caused through cosmic rays. I mean, these guys, I don't know why this isn't a bigger deal. This is peer reviewed shit too. I guess I got the paper somewhere here.
You understand that you are exactly off on your definition of what a solar minimum does, right?
No, I'm not actually. You are. You're under
Oh,
the impression that a solar minimum means there'll be less cosmic rays
correct.
penetrating the Earth. Yeah, but you're
Less
wrong.
sunspots, less solar flares, less
But
disruption
it's
of the
cosmic
magnetic
rays don't
field.
just come from solar flares, knucklehead.
Well, wait a minute, hold on. The solar minimum, though, is when the sun is at its minimum activity. So you're saying that the cause is backwards from what it should be.
A lot of the things you think are backwards than what they should be.
Well, what I'm saying is I've seen the paper you have. It's interesting. Sort of
Then you would have read that during the solar minimum, we have a higher influx of cosmic rays than the solar maximum. You'd have read that initially, right in the beginning. Then, if you had read the paper, get back to me on that.
what paper are you talking about?
Any paper, it's common knowledge. Right here. Who's abstracted the PubMed paper? WHO's pronouncement of the 2019 novel COVID virus outbreak as a pandemic disease came months after we published a warning that the present deepest minimum of the sunspot cycle would be likely to facilitate the onset of a viral pandemic.
Oh,
Does that say minimum? It does, doesn't it? It's crazy. It's the opposite of what you thought it might be. It's just not as intuitive, are you, as you think you are.
From shit shoot. You got something from shit shoot. Using that as a...
Oh, I got that from shit shoot?
Yeah.
Oh, yeah? You want to put money on that too?
Well, it's the last thing you... Well, wasn't it?
You don't? Or do you?
Is that the last thing you poked up there?
Yes or no, man? You want to put money on it?
Is
You
that
got
the last thing you
attitude.
put up there?
You got your attitude on it. You want to put your dollars on it? How about $50? Here.
You're going to get about a $50.
PubMed, motherfucker. .graph. And by the way, it's the cosmic rays come in when we have a solar minimum because the sun regulates our magnetic field.
The sun regulates the
Less.
magnetic field?
Yeah, I've been trying to tell you that for, I don't know, ever since I ever got on Discord.
How does the sun, what's the sun got to do with our magnetic field? Just
Well, I guess you'll learn now. Well, why do we have a less? I don't know. You tell me. Why during a solar minimum do we have less of a magnetic field around Earth? And during a solar maximum, why do we have more of a magnetic field around Earth?
So what would you say that
the question you should ask, since those are the obvious observations.
Now, what is the cause of the magnetic field in the first place?
Well, I mean, with your theory, the cause of the magnetic field is a dynamo inside of Earth, which I don't know why the sun would change that in any way.
Well, that's just where.
But in reality, the sun changes it in weird ways, right? Because less sun, less magnetic field. Now, if we're telling you that the sun is what gives the Earth the magnetic field that it has, at least a certain intensity of it, like an electromagnet to a steel ball, kind of. So if you're sitting there with a minimum, you're having a less effect on the things around you in your field. But in a maximum, you'll be having more effect on the things around you in your field. So why would the Earth grow a stronger magnetic field during a solar maximum? You would think that the opposite would happen, wouldn't you? Because he thought so. So there might be finding out two things at the same time. But for one thing, the observation still stands. Cosmic rays can penetrate Earth's magnetic field.
Are you conflating? Are you conflating
protons from outer space, not just the sun?
Are you conflating the Earth's magnetic field with the magnetosphere?
Oh, probably, yeah.
Yes.
Because
okay.
that's what. Yeah, because that's the magnetosphere is what protects the Earth from the, cosmic rays, and the magnetosphere is what we measure as Earth's magnetic field in the first place. It's an extension of it. What? That's where it happens to interact the most with the external plasmas and bombardment from the sun.
Right,
which they call
decreases
neutral,
during the solar
neutral,
minimum.
But it's positive. And it doesn't matter if it's neutral, if it's positive or whatever, because plasmas separate charge on their own. They don't need help from outside forces. They do it on their own when they move, especially on a surface of a sphere.
Okay, so the magnetic field doesn't change much,
spheres,
but the magnetosphere changes.
Right, and different size spheres, that are like charge attract. They don't just repel, they attract. A lot of stuff is flippity floppity over on its head because you thought it was one way when it wasn't. And you keep on applying that, because it's just rational. It's what we do. Apply what we think we know to other areas, and then they don't seem to work out anymore. And that's what's happening in this space age today. And I predict that that James Webb Telescope is going to show us that we have a lot of dust that we didn't see before, and that dust with a small electric charge will be plenty enough to take the place of dark matter. And it won't be any special needs or any special matter that we don't understand or can't see, other than maybe plasma crystals, being that's a new soft state of plasma matter that they're calling now the fifth state of matter. And they exist in the natural environment of space too. So these are all real interesting new developments. And nobody in gyms that's been arguing with me about the electric universe is liking any of this new shit. And they're hella mad that I was right about vitamin D too. A year before Fauci came out and told their dumb asses that I was right.
Oh, broken clock is correct twice a day.
Yeah, except it's the same shit. I'm not fucking saying a bunch of different shit. I'm right about the same shit that I've been saying. It seems intuitively I have a leg up on.
Well, except that your whole concept of the electric universe is shit, but okay.
It's easy for you to say. You don't know shit about it.
You're right. I don't know shit about the electric universe.
Right.
Because it's fake and made up in your head.
Sure. Yeah. Whatever you think, dude.
Do you have any proof of this?
Yeah.
Any science that backs it up?
Oh no, I can't prove that I didn't just make it all up in my head, because I can't prove that I'm not just a brain in a vat.
You ask that. Ask you any evidence of your electric universe theory.
You are really shallow, aren't you? Jesus Christ.
Well, the brain in the vat thing bores me.
That's all there is proof of the electric universe.
I'd settle for one little bit of it, please.
Since before we can see the magnetic fields that thread the nucleuses of black holes, we told you that that was a necessity. Everything out there was connected via magnetic and electric forces, and that those were the operative, that they would need to be there as a necessity to operate that the functions of what you're saying is the black hole would be the center of a galaxy. Been saying that since the beginning. And then when you found them, they were unexpected, but ad hoc immediately right into the theory. Oh, now we know that the black hole generates a magnetic field that perpetuates for light years through the. Yeah, shut the fuck up. You made that up. Because before you had no reason for any of that. They weren't there like that. No coaxial inflow and outflow going into the polar, nucleus of the jets of AGN. There was no reason for any of that, but it was a necessity in the electric universe. I mean, and there's no reason for any, what do they call it? The cosmic web, to have filamentary structures that rotate as a function of a Birkeland current. I mean, there's no reason for any of that in some gravitationally based model. They're supposed to be free willy, flapping around. Well, that's exactly what you see in an electric. Yeah, that's exactly what you would see in a scalable version of the electric function. It would be a necessity. And they just found blue shift and red shift at the top and bottom of a tube that goes cross sideways, indicating rotation. they're looking at this thing and they're going, well, shit. I mean, look at the quasars all lined up, and look at the black holes. I mean, the galaxies creepily lined up together. There's a bunch of weird shit going on they can't explain at all in the standard willy-nilly gravitationally based model. But I mean, in the electric universe model, that's all normal shit. You would see polarly aligned fucking galaxies lined up along the same axis of a cosmic web cylinder, which is just a huge influx of charge over a mass surface area. Yeah, 1 cubic square inch of it doesn't mean much, but you add the whole surface area up and you've got a Goliath. So, I mean, you guys played around. And we can't even, we were sitting in situ. We were sitting in, what was it, the moon of Enceladus was a Cassini mission. And it was just sitting there, not measuring 95% of the electric current that was later measured in that same place, the same situation. 95% of the dust and the stuff that they didn't get either. So there's why we only see 5% of the universe. I mean, because we're standing right in the middle of it and don't measure it. It was 200 million electron volts that they recorded that's there. And that wouldn't come from some cryojet. That's an electric discharge event. You guys are crazy, man. Keep telling people bullshit stories and then coming back acting like I'm the one who's telling fucking fantasies and making shit up in my head. None of the data supports the standard model ever. It never does. You always come back with some new unexpected shit by you guys, by the way, unexpected. So, NASA will turn around and go, well, it's been theorized for over 50 years. Yeah, but by a guy you wouldn't publish in American journals. Hannes Alfvén theorized it. Don't try to take credit for Hannes Alfvén. I love how they did that.
So, I mean, if you've got this great theory that explains everything, why aren't you like some famous scientist that knows everything?
Why am I not Hannes Alfvén? The guy
yeah, why aren't you like sitting on,
parroting?
why don't you have some like, nice cushy job,
doesn't make
like,
any sense.
Telling people all about the electric universe.
What makes you think
all
I
the proof
don't have a nice cushy job?
Well, I mean, telling people about the electric universe. You can just sit there and, people would come and pay you to
How come
listen
I can't be a fan and a proponent and I have to be the director and the leader? Is that your big argument, dude?
Well, my big argument is that
you're degrading comment. You do that all the time.
You think it's good
why aren't you
you've got
this?
all the
Why aren't you
data,
Nobel Peace
but
Prize
you don't
winner?
have the data.
Why aren't
Otherwise,
you
you
this
would have
famous
like
person?
publish it and
That's
send
your
out the
answer
peer
for
review
everything.
and, flip the world
You're
on its head, get a
belittling.
Nobel Prize.
Just your
Why aren't you on the
belittling
Howard
tone
Stern
voice.
show, dude? I mean, you're really good at being annoying. You sound like a fart.
Yeah.
Why aren't you on the Howard Stern show, dude? You'd be great there. Fucking joke, man.
Always go down that path.
My question still stands.
Always.
Hey, what's up, buddy? How you doing?
Yeah, good, man.
They just get hella mad because they argue and get polarized against me, and they take bets in the room and they clash personalities, and it turns out I'm right, and they have to they have to eat that shit.
Oh, Graham, come on, man. You know that a lot of the times that when you get heads up against people and they analyze the documents,
No, they break it down
sometimes
to some other straw man or different part of an argument or something that I'm not trying to even make. And they tear it down to what I'm saying all the way into something different. And then they win that argument. That doesn't matter. Or they go, oh, look, you didn't pronounce this word right. Therefore, throw out the baby with the bathwater. They can suck a dick on that. And you can't act like that they've ever done anything significant that tears down the electric universe, or the idea that this COVID is being hyped. There might be something to it, but it's being very much hyped up.
850,000 people will disagree with you.
Again, you don't know that.
4.5 million people worldwide will disagree with you on this.
You really don't know that, man.
Oh, I see.
How many
Just all
billion
one big
people on the
fake story.
planet?
Gotcha. 7.
the death toll right now is at 5.5 million.
5.5? Oh, I'm sorry, I'm behind the times. 5.5 million. 7.2
Yeah, died
billion.
with COVID, not of COVID. You got
Doesn't
to
matter.
remember that, man.
Doesn't matter.
You're talking about people who had comorbidities,
Well, you're like
who
saying
were dying of other
you're
things
like
already, and you can't
this.
tell when they would have died or not. You shut up for a second. And just because
Oh
they're
fuck!
positive
You've
with the
been
common
talking your
cold,
ass
you
off.
say that they died from the common cold, and then you think touting those numbers, you're not being dishonest. You know you are.
You're like the AIDS guy in the AIDS epidemic. Oh, no one ever died of AIDS. They died of some rare cat thing. Fuck.
What the fuck are you talking about, man? You're being a clown right now.
I'm being a clown? No, sir. You are.
Of course you are.
You are bozo right now.
You're like that guy in that TV show where they throw golf balls in the little red buckets. Oh,
You're
you
like
just said his name for
bozo,
me.
saying that
Yeah.
I've got all this evidence, but no, I can't
You
give
are
it to
the bozo projecting at me right now, calling me bozo. Hilarious. Here, let's honk your little red nose one time for everybody in the.
That's hilarious.
Wow. Knowing damn well that I just showed you another paper that showed another cause besides COVID for autoimmune diseases and heart conditions, and those are cosmic rays due to solar minimums, which you just swore up and down were it was completely backwards because your smarty pants fucking knows better, which you just got your nose rubbed in poop like a bad puppy who pooped on the carpet. And no, you don't fucking tell me that cosmic rays are more during solar maximums and less during solar minimums, you knuckle-headed puppy.
But what is
outside with
what
that?
What has solar rays got to do with COVID?
He doesn't
Ain't nobody
know.
talking about solar rays, you knucklehead.
What?
Talking about
Nobody's
cosmic
talking about
rays.
solar rays. I'm sorry, I'm not. I thought you were the other dude. I'm not talking about solar rays. I'm not trying to be.
Don't call me knuckle.
He's talking about cosmic rays.
Yeah, it was cosmic rays. He was trying to tell me that I just posted a paper here supporting and mapping out of graphing the times, and they line up with 100 years ago Spanish flu. They line up with the
I think.
during the solar minimums, right? They show a relationship and they actually show a causative effect of these protons and the protons on human health, and the human gets overpopulation, gets more autoimmune diseases and stuff, or more. It might even be more, when they come to find out what's really going on, they might find out that the cosmic rays are affecting the way your exosomes, and you're creating these spike protein type, pathogens in our own bodies due to the mutations.
What? No, that's bullshit.
Yeah, you always say with your knee-jerk reaction that it's bullshit.
No, it is. To you, that's correct, because you say so much bullshit that every once in a while you sneak in something right. It's difficult to tell in the big pile of bullshit.
Well, I just told you it's not known yet, but it may be found to be true soon.
May be found to be true.
And then I said, this is literally me putting out another prediction. And so right now it can't be known because it's a prediction.
You making shit up.
Hasn't been studied. Yeah, but see, this is the thing where you should have been paying attention the whole time. Because every time
the problem is you just talk, and listening
every time
to you
I
gets
do make
tiring.
one of those predictions, that's the funny part, right? I mean, I end up being right.
No, usually not.
Oh, enjoy your vitamin D, remember?
I don't give a shit about vitamin D.
Yeah, you were wrong about that too. And you were wrong about the cosmic rays just now. I mean, why do you think that you're going to be right on the next one? It's got to be. You just got to be right on the next one, right? It's a numbers game.
Well, no, I mean it's a numbers game with you. You make so much. You throw so much bullshit out. That you throw so much bullshit out.
Yeah, but here it's different between you and me. You're trying to tell me that I roll the dice and maybe I'll be,
It's correct. You talk. Your whole idea of the electric universe is bullshit. But every once in a while, you find some fact and you say, "Oh, that's caused because of the electric universe," and it's not.
You must feel really bad about yourself, huh?
I feel really bad about you, actually.
That. Yeah, you keep saying that dumb shit. You have no idea what you're talking about.
Says the guy who has no idea what the fuck he's talking about.
Oh, baby.
You can't say I don't know what I'm talking about, because I clearly just taught you about the solar minimum and cosmic ray
taught me
influx.
one
I clearly
fact.
just taught you that.
You taught me one
Yeah,
fact.
but you had that same confidence as you do right now.
You taught me one fact.
Yeah, but you had the same confidence.
In the meantime, though, the total radiation from the sun goes down, and the cosmic rays happen to go up.
You're so dumb.
Well, I know.
We're not
You're saying
talking about
cosmic
radiation from the
rays.
sun.
You said cosmic rays, and that's correct.
That's
they
twice
go
now
up.
you tried that dumb shit, man. You don't know what even is being talked about, do you?
You have no idea what you're talking. I mean, it's not due to the electric universe. You're right. The magnetosphere, which is part of the magnetic field, because it has less interaction with the sun, is weaker, and a few cosmic rays sneak through.
Yeah, it's weaker. Why?
Because there's not as much shit being thrown at it from the sun.
Right. So the magnetic field, the sun throwing shit at the earth, strengthens the magnetic field of the earth.
Interacts is a better way of saying it.
Huh. So how would we just shut off the sun throwing shit at the earth and be able to tell, does it still have a magnetic field on its own? When I take a plot, hey, what's going on in that background back there? It's flippity flop, loud. Right? I take I've taken
oh, by the way, it looks like the Spanish flu.
And I throw it towards a positively charged environment.
Looks like the Spanish flu actually happened during a maximum of the solar cycle. That's interesting. See, 1918 was the maximum. 1917 was the maximum of solar cycle 15.
Oh no, it's a grand solar minimum. It's the maximum during the grand solar minimum. You're so dumb.
What do you mean?
This is why we don't play together in the same park.
1917 was a maximum of solar cycle 15.
It was a grand solar minimum. It was a minimum. It was a maximum of a minimum. There's two oscillations, right? There's a bigger oscillation and a lower oscillation. And during one of the maximums of the lower oscillation, that's still a very much less output. It's a minimum. Like it's an 11-year.
Modern maximum started in 1914 and ended in 2008. Huh. That doesn't sound like a minimum. So it's the beginning of a modern maximum. Modern maximum refers to the period of relatively high solar activity, which began with solar cycle 15 in 1914. It reached a maximum of solar 19 in the 50s. That doesn't sound like a minimum.
Checkmate. Thank you. Whoa. It says right there in the paper, during a sunspot minimum, this is 2018, 2019, right? The deepest in 100 years, such as we are now witnessing, two space-related phenomena could have an effect on the disposition of viral disease and potential pandemics. Hold on a second, sweetie. Let me mute this. What's up?
Maybe let me mute this so they can't hear me smooching. What are you working on, Bandy?
I'm working on a coffee table.
Hold on. In the bathrooms of the schools? Yeah, for their children. Oh my God. Is this real? Yes. So there's a lawsuit. Was it in Iowa? There's a lawsuit. There's some kids, right? Some parents are letting their fucking little rugrats identify as cats and dogs, right? And they're trying to sue the school. I literally just said something about this the other day as a joke. I was like, I identify as a cat. Are you gonna put okay, you know what I mean? They won't put kitty litter boxes in the bathrooms for them to go potty on at the schools, so they're going to sue the schools. Their children identify as monkeys. I mean, cats.
I'd smack the parents in the back of the head and send them home.
Somebody needs to do that, man. This is when society is like, okay, we've had enough, right? Their parental rights should be taken away because they're clearly not teaching their kids right. Yeah. I bet you these are the same fucking types of people just playing video games all the time. You know, they have kids and they're like, just whatever. I have no idea. How could you be that crazy?
At least they didn't identify as monkeys, because monkeys throw shit at you.
Yeah, they sling shit on walls and stuff.
Yeah, well, you are monkeys. Tried that shit and they got beat up for it. What are you doing?
Why do they do that? What's the biological reason for it?
It stinks, and you need to go away. So,
biological reason for what?
They think it's funny.
Do they do it in the jungles? Do they sling their shit at trees, or is it only when they're caged?
No, they do. I've seen it done at the zoos or enclosures like that, when the visitors will come up near the cage and then they'll throw shit at you.
Yeah, I'm just wondering if it's a product of captivity, if they do stuff like that in the wild.
Hello. I'm pretty sure they do it in the wild as well.
I always piss the gorillas off when I go see the gorillas. Used to. I haven't been in a long time, but every time I go to the gorilla cage, he comes and bangs against the window at me. I don't know why.
Why? Because you're uglier than the gorilla, Harry?
I think that's it. Yeah.
I thought you were gonna say, and I just take a handful of peanut butter and throw it right at the fucking glass. Like, why?
Throw your shit at me, monkey.
Hell yeah. I wonder if anyone's ever fucked with a monkey back, you know, with peanut butter. Oh yeah? I really don't wonder.
I noticed a picture earlier that Rui put up of a bit low in vegetables in the vegetable department. Is that something I missed in the conversation, or was nothing to worry about?
He was saying all the truck drivers are quarantining because of the Omicron or whatever, so there's no food on the shelves.
That's true. That's true. Supermarkets are getting pretty bare at the moment.
No, it's not toilet paper anymore. Now it's vegetables and other goods.
Yeah, but Toll, who's Australia's biggest transport company, and are responsible for all of Coles and Woolworths deliveries, their contracts have been cancelled because of COVID. Because they haven't been able to live up to their end as far as delivery times is concerned. So now Coles is undertaking a massive task of starting up their own supply chain and trying to put that in place. That's why we're seeing a lot of bare supermarket shelves at the moment.
Yeah, but then what would happen in the same scenario with the people working for the company, with the having the needle, and then they can't go to work unless they've been checked, and they're going to end up with the same problem. Don't matter who runs it.
Yeah, I know, Terry, but yeah, that's the story that's out there at the moment. It's been on the news and everything that their contract has been canned.
Now, I don't watch the news. I don't.
Yeah, I mean, if you've got a driver issue with the open market, why wouldn't you have that same issue in a private company like that?
Yeah, true that. So as a result, too, of the supply chain being cut off, there's a lot of panic buying going on as well. So you've got those two factors are just compounding everything. You would have thought by now, 2 years in, they would have been on top of all that.
I heard Rams was saying something. I'm not sure exactly what it was referring to. I think it was some like comedy sketch, and the theme of it was it said, post COVID, 40 years later.
Yeah.
I imagine they'll blend this into whatever they're going to do next, but man, this is just stretching it out for sure.
They're getting their money's worth out of it, that's for sure.
Well, look at the children that have been born into it. They're going to grow up by the time they get to school and everything. They'll think it's just normal life for them, the way things are going.
Yep, fear and masks and being afraid of other people and afraid of the air and never seeing anyone else's face and getting injections all the time. Yeah, it's pretty bizarre.
When you see pictures of schools and they've got checkerboard patterns in the playground where each child can stand, so they're 1.5 meter distance apart from each other, that is really sad. That's really sad.
I forget who was telling the story yesterday that they were at work and they put in a thing where you go into the lunchroom and you're only allowed to sit in the lunchroom on your own while you have your lunch at work.
Yeah. Went down to the doctor a few weeks ago, Terry, and all the seats in the waiting area, they have it's like police tape on every second. You say you have one free seat, and then you got 2 seats that have this tape over them. One free seat, 2 seats that have tape all over them.
Yeah, well, that's how you distinguish that 1.523 mil or whatever it is, distance meters thing, whatever it is.
Yeah, which is just ridiculous to start off with, really.
But see, with that distance thing, I correlate to that back to the day when when we all used to say about our personal space thing. You know, when you standing around in a group or in a line, and people would say, "Oh, yeah, watch me personal space," whatever. Well, to me, that's the same thing.
Yeah.
I wonder if it's more of a thing now because it's got an instruction attached to it.
Yeah, you invade my personal space.
There's
Now we
a
know why.
difference between choosing to not be close to someone and being told you're not allowed to be close to someone. Those are two very different things.
Yeah.
Well, that's with a lot of rules, isn't it? There's a lot of rules out there. You go, "Oh, yeah, what's this rule for?" And then you've got to find out what it's actually for before you can understand it.
I mean, if you think about it, one is you saying, "I would prefer you not to be close to me." That's freedom of association. The other one is the government saying, even if you want to be close, you're not allowed to be. That's tyranny. It's the difference between your freedom that you were born with and the government being tyrannical.
Do you think it'd be valid, Bob, even if all of the quote unquote science was all correct and everything's true about all of it and the 6 feet and the masks and the health of the world, if all of that was 100% true, do you then think it would be valid, or do you still think it'd be invalid?
It wouldn't be valid to tell two or more people that want to be near each other that they aren't allowed to be near each other. They could validly make rules that say, if somebody says they don't want to be near you, you have a requirement to not go near them. That in fact we have that. It's called a restraining order. That's valid. Okay? Because now you're just basically what you're saying is, I don't want to associate with you, stop associating with me. That's fine. It'll never be right for the government to say, you two who want to associate with each other, you're not allowed to, because we say science. Or, whatever other excuse they have.
Yeah, well, I mean, they've already been doing that. Obviously, all the limitations of gatherings and not allowed to see your family members. And I mean, it's already been happening, obviously, for pretty intensely in terms of all these limitations. So Terry, it sounds like you're not in support of this stuff, or are you not in agreement with all this stuff?
Are you talking to me, dude?
No, I said Terry, but maybe he stepped away.
Yeah, I wasn't. I'm talking to my wife right now. She answered yes to it, and you said no. Yes. Hold on.
Does she agree with you on your viewpoints on things?
Oh yeah. She brings me information on it all the time. Just make me a screwdriver, babe. I'm just kidding. No, she's like, what? I'm straight. I was gonna say, what did he say? I don't know if I agree or not, because I had to step away. God damn it. There we go.
But
just tell me who said it, and I'll tell you if I agree or not.
Well, I think a lot of this deals with like this fundamental idea of health sovereignty, that each human does have their own health sovereignty. Like, sort of like you can choose what you want to do with your body. You know, if you want to get a tattoo or if you want to eat certain food or whatever. Obviously, if you're gonna harm someone else, that could be an issue. Of course, they're making it sound like they've kind of combined this idea of health sovereignty and then hurting other people with distance and breathing and all this stuff, to where they've kind of combined those.
It's like how am I? You know, that's a force of nature. It's got nothing to do with me particularly.
This meme I posted the other day, I'll post it again. It's just pretty perfectly describes it. It's got like Bill Gates and Fauci, you know, in a car mechanic shop. There's a 99% chance your car will run fine, but we recommend you service it with an experimental oil that may destroy the engine. Nothing is wrong with your car, but do it anyway so others will feel better about servicing their cars.
Yeah. So true.
So I guess it's gone quiet. Anyone have a topic?
No. I mean, I had it for a little while there. I think we had fun with my addition to the show today. Now I'm scratching lotto tickets.
well, I was gonna kind of argue with that last thing about doing the thing with the car, but I'm too tired to argue.
So take the L. Take the L then. I'm just kidding. That's annoying. Come on, baby. Give me a finger. Okay.
I have a question. Is flirt a pejorative term?
Just like any other term, it would depend on the person who's using it. What is their intention in using it? Just like every other word. There's no such thing as a bad word or a wrong word. It's how you choose to use the word that determines whether or not it was right or wrong.
Yeah, but if words come, if you text something and you don't know the person who's texting you, then yeah, what impression would that cause? I mean, if you call a random person a son of a bitch, that doesn't have a nice connotation, right?
Basically, I think the idea there is that if you don't know the person that's saying it, you would fall back on your personal experience, and in like my personal experience, usually the people that are using it in a negative way. But that wouldn't. I could then accuse that person, hey, why are you calling me a mean name? And they could just say, I didn't mean it in a mean way, and then I wouldn't have any proof that they did mean it in a mean way. I would either have to think that they're a liar or just believe what they said. They didn't mean it in a mean way.
Right, because I thought it was just short for Flat Earther. And then I almost got banned on the server for calling people Flat Earth. But I just thought it was really convenient because it's, shorter term. But apparently they saw it as pejorative. Right? They didn't see where this came from.
Yeah, I guess it depends on level of. If you're giving them enough food, a lot of people don't care about that shit so much. I don't think.
Well, you got like the people on Bev's server, like they've actually taken issue with the term flat earther, and they refuse to accept the term.
Oh yeah,
and,
he's one of the he says like he's not a flat earther. Like he'll like stop the conversation basically, to declare that he's not a flat earther.
He's a
really annoying.
One of them.
He also will claim that the Earth is not flat as well.
Because of elevation change. Because of topography, right?
And like that's fine. Like I don't have a problem with him doing that. If he thinks it's important to clarify that for something
no one does.
I don't know about, that seems legitimate. Like there might be a very important reason why he thinks that needs to be clarified. It's not flat. There's elevation changes. He doesn't think it's flat.
But that doesn't make sense because when we call people flat earthers, we don't assume they think the Earth is perfectly flat. We all mean like flat in a general way. If you discount topography, what's left is a flat surface. That's all everyone means. No one means like
now you're back
flat.
So you were thinking that like Flurfer was short for flat earther, but even flat earther itself, depending on his experience, it could have been used as a pejorative against him so much that he wants to make sure every time that it's clarified. When you say flat earther, that's wrong, and it like you shouldn't be associating that with me.
No, it doesn't seem very analogous because he doesn't clarify. It is pejorative. He clarifies that flat earther would mean the Earth is flat. I don't believe that. I think there's topography. That's stupid. Maybe he's using the wrong. He's giving the wrong reasons why he doesn't want to be called that. Because this reason that he gives doesn't make any sense.
If we're gonna talk about what's stupid in the first place is people thinking that flat is a shape. It's not. So like saying what shape do you think the Earth is, flat or a sphere, or flat or round? Like one of those isn't even a shape. So you're asking a stupid question in that case.
Round isn't a shape.
Like a sphere.
Round's not a shape either. No.
Yeah, but I think the message is pretty clear when you make that question. Even though it might have technically, you might not be using the right words there.
You're gonna say that's stupid. Like, go to the source then of the stupidity. That stupidity comes before his stupidity.
But but when he makes that argument, when he says that even if I don't make the mistake you just exemplified, if I just ask him if you're a flat earther, he's gonna say no, and there's no mistake on the question, are you a flat earther? And he's still gonna say no, and gives an argument that doesn't make sense because the word flat earther doesn't mean people who think the Earth is perfectly flat.
I can give you a different example that would be like kind of an analogy that has to do with like different religions or whatever. So I would consider myself to be a Christian. Okay, there's a lot of people I think out there that if I told them what I believe, they would say, "Oh, you're a Protestant." Okay, I'm absolutely not a Protestant. Okay, that's not what I am. That's not and not even remotely close to that. Okay, but because of the way I would describe what it is I believe, they would lump me in with Protestants because they would say, "Oh, well, you're protesting the Catholic Church just like the Protestants, so we lump you in with that group." But it's absolutely false. I'm not one of those. Okay, so to me it seems like that's what he's doing. Is there's a group that's been identified, and they want to lump him in because he shares some things with that group, but he wants to make it clear that that's actually not the thing that he's describing, even if some of the things are similar.
I mean, I would also be embarrassed if I was compared to that group, but I think he would fit the description.
But he says that he doesn't. So, and I mean, he gets to decide, what he is or isn't for himself, and he can continue to argue that. Now,
Then
you can
he's
look at it and
changing
say,
words'
well,
meanings.
okay, here's the check boxes for flat earther, and you check all the boxes, so I'm going to call you flat earther. You can do that. I'm just
Well,
saying
there's one
that
box.
from his side, he probably thinks he doesn't check all those boxes.
Well, there's
But
one
Web
box.
Extra boxes.
does it.
Yeah, there's
Web
only
does it
one box.
Web does it just to be strict, because flat has a certain meaning to him. So the Earth can't be flat because there's topography. So he's
Yeah,
just going the extra way to say
right.
that
He might be
yeah,
being
the
very
Earth
strict
is
with the
flat.
language, which
Yeah.
I don't really. I think that's fine. Like you get to set how strict you want to be with your language. There's things that I won't just give people the word. Like, they'll say, well, this is what it means to me, this is what it means to everybody else, and I'll just say, I don't care the way you define it, or if you want to use your source to say, here, this is what it means, you can do that for you. I'm not going to give up on this word. Here's what it means to me, and I'm going to continue to say that.
It's just like when I could do the same if someone asked me, do you think the Earth is a sphere? I can say no, because a sphere doesn't have a topography. So the Earth can't
There you
be a
go.
sphere because there's
Exactly.
topography.
Right.
It's a globe,
And
but
I
it's not
think
a
that
sphere.
it's pretty clear now that the ballers that get on here, they don't actually think it's a sphere, do they? That's not actually what they think, because, like you said, the sphere wouldn't have
Not a geometrical
topography,
sphere, no.
and the sphere
Yeah.
wouldn't measure the same, as far as I know, to what they consider to be their measurements. So I don't think that they would actually declare it to be an actual sphere, but they use it for quick speak or
Yeah, it's
whatever.
colloquial usage of
Yeah.
the word sphere. Because I mean, a basketball isn't a sphere because it also has the dimples and the lines.
But it is spherical.
Yeah, spherical it is, but not a sphere. I don't think you can ever get a sphere because if you go to
It's a
the atomic
geometrical
scale,
term, right?
yeah, and I mean, some people think that geometry somehow proves things in reality, like if you have a vertical and then a horizontal, and then the Earth is flat. But yeah, I mean, it's weird because it's maths. It's not.
Yeah, math is entirely independent of reality. Although we might fit many of the mathematical concepts in the real world, it's not dependent on the real world.
Yeah. And with people using it as some proof, like if you want to be pedantic, you can ask what is vertical in reality? How can you prove that something is vertical? And you just can't.
Or like Alice and Bob paradox.
What paradox?
Alice and Bob paradox. No, Kiwi's paradox.
Oh yeah. That's I don't.
That prevents spheres to be possible, right?
Yeah. I don't know how someone who's an adult can look at that and think, yes, this is a good argument.
His own people argued with him about that, and he's kind of quieting down about it. He'll still argue it, though.
Yeah. But it's interesting. I think Mr. Sensible, he was in Bev's the other day, and they are doing something with the Black Swan, showing that it's a bad argument. Because there is a lot of assumptions in the Black Swan argument.
I believe that a lot of their arguments, even the ones that come like Alice and Bob or whichever one, if they wouldn't hang their hat on it and say globe destroyer, and shit like that, and attach these absolutes to their arguments, I think that they would actually have better luck arguing them than putting these absolutes on them. Because you can disassemble them immediately.
I think the argument with the sextants, that's a kind of a bad one, because if you assume that the Earth is flat and you're actually making a triangle with a sextant, then nothing works.
Yeah, that's exactly what I was trying to point out to George recently, and I even I sent him like a rectangle triangle that is twice as wide as it is high, which means that the angle, if you calculate the angle of the diagonal, gives you something like 26.6, I guess. But if you do it with a square, you have 45 degrees. But if you use those degrees to get how far you are to the GP of a star, one should give you twice as far as the other, because the rectangle is twice as large as the square. But it doesn't, because if you multiply 63 by 60 nautical miles, of course it doesn't give you twice as 45 times 6 nautical miles. So I mean, it should be obvious why it doesn't work. And I'm actually right in this moment creating a visualization webpage to try to make it as clear as possible.
Do you mean the George from Faroe Islands, or where was he from?
Yeah, that George, yeah. The one who speaks Portuguese.
Yeah.
Good luck with George.
I was talking with him in Athens about the triangle, and he said that you can only know the distance, when you make the triangle, you have to have a 45-degree angle to the Polaris to know the distance from the GP and the altitude of Polaris. Said it doesn't work in any other way.
Yeah, well, he never did the math then. Because I mean, just pick the angle from the horizon to 3 random celestial bodies and try to work out where you are. So yeah, I mean, I bet none of them ever did it.
No, it can't be done, assuming a triangle and a flat plane.
I mean, if you go to the live stream, just open, there you have a visualization of how it would work. So I mean, as you play with the angle, and I'm just forcing the distance from the observer to that initial point to be proportional to that angle. So the distance is working as the sextant says it should work. Then where the star should be changes every time you change the angle. So if you're close, the star should be higher. Yeah, I just did.
Nice.
So if you put that on a sphere, it always points to the same direction, which means it's something really far. But if you put on a surface, a flat surface, it keeps changing where it's pointing to. There's no fixed point you can create that is going to have a fixed location as you play with the angle. So yeah, no sextant argument for Earthers.
Then if you jail that to, I don't know, maybe QE or someone, they won't go that far. They'd say that, no. You have to stop at, okay, welcome to Flat Earth.
Yeah, or George says that a lot.
Yeah, it happens a lot there. If you say something like, okay, let's assume this. Okay, welcome to Flat Earth, no further discussion. It's like, okay, this is honest.
I got a refraction equation for that. It does work on a flat Earth. Just you got to apply a refraction equation.
That refraction demonstrable.
What?
Can I see your refraction equation?
Yeah.
Yeah, is
Hold on.
that,
I'll post the video.
yeah, is that
If you
refraction
want me to
demonstrable?
say it, it's 90 minus A over A and times D times point A. But I'll post it.
Well, I can just use angles above 15 degrees, and I'm sure it's still not going to work for the flat Earth. Because if I'm getting distances to things that are above 15 degrees, the difference in their position is pretty negligible. So if you're dealing with things from that angle above the horizon, and you're using the sextant, you don't even account for refraction. So if there's inconsistency,
that's how it works on a flat plane in my model. It's a refraction equation.
I'm
make
not
all the distances.
arguing.
It makes all the distances correct.
I'm not explaining how it works on the flat Earth. I'm explaining how the sextant is used. So
well, you just said that we don't have a way to do that, and I'm telling you that we do. And now
I'm saying when people are
some other argument and interrupted me too. All right.
Oh, well, you're misquoting me. I'm just clarifying. What I said was, okay, I don't recall my exact words, but what I mean is, the way the sextant is used when people work out their position using a sextant. If the stars are in high elevation angles, they don't make any corrections for refraction, right? That's how they work out their position.
There's very little correction. Same thing in my model. There's hardly any correction at all until you get to about 10, 15 degrees. There's hardly any at all. So, it's basically the same, man. It's basically the same.
So it's still not gonna work, because if I get, for example, the problem, a very easy to visualize problem arises if you compare 45 degrees to 26.6 degrees. They're very easy to solve, and the inconsistency becomes pretty clear, and they're both above 15 degrees. So yeah, no refraction to help you there.
I recommend you just spend a couple hours outside looking at airplanes, and how when one starts to go away from you, it looks like it's just going straight down. And when one's coming towards you, it looks like off in the distance, it looks like a space shuttle. It just looks like it's way off in the distance. It's just going straight up. And then look at planes way off to the side, and you know that they're flying level, but they look like they're flying like angles upwards. I mean, you got to really get a feel for perspective and understand that it's as much as it is refraction, it's perspective. It's kind of like a perspective equation. A refraction. It's like a refraction mixed with perspective, but it's just an equation. Basically, it makes the distances work perfectly on the planet Earth.
Perspective doesn't affect directions, which is the only thing being used in the sextant when looking to celestial body. We are only using the direction.
That's all you use in the equation is you just get an angle and you do the triangulation and get the distance, and then you apply the equation. That's all you do. There's no made up numbers, no 7/6R bullshit, no fucking arbitrary numbers. Hold on, let me finish, bro. You ain't got to keep interrupting me. It's just the angle that you measure. And the distance that you triangulate with the equation applied.
That's it. Yeah, the angle that you make, that's all. No perspective.
Are you saying that how can it still be a triangle if you have bent lines with your equation?
Let's make a very easy example, right? So according to your calculations, suppose
you haven't even looked at it, and you're just automatically
no. I'm going to give you values. And you give me the answer for your calculation, right? Do you have it right there with you? Because if you do, I'll ask you how far things are given your calculations.
Bro, I've already
show you how it doesn't work.
Examples are on the video. You're gonna have to watch the video.
No. I want to test a specific examples.
Yourself, bro. If you can't do it, then you're not worth talking to, bro. So you got to prove to me that you can even do it.
It's an opportunity for you, Brian, to put your numbers into what he's talking about and see how it works.
I don't want examples.
Numbers in, bro. There's no putting numbers in. You measure an angle. You measure the angle, then you triangulate the distance from that angle. So you could throw out an arbitrary angle and you can work it out. But like I said, you need to prove to me you can work that out before we even have this conversation, because you're just denying it based on nothing at all, really.
No, it's not based on nothing. I can explain you, because if you're agreeing that for angles that are high, for elevation angles higher than 15 degrees, it doesn't make that much difference, then you still is going to have the same problem as all of them do, because the problem arises from angles that are actually higher than 15 degrees. You don't have to go below 15 degrees to find geometrical problems of using a sextant on a flat surface.
You mean right up under the star, right?
No, I mean the elevation angle from the horizon to the celestial body.
Okay, well, look, the sextant's not used lower than 30 degrees. It's 120 degrees. It's 60 degrees each horizon. It's not used less than that. It's
No,
grossly inaccurate. Underneath 30 degrees.
Model being applied,
You
it
can
appears
use it
chicken
below
within
30.
on the edge.
I want you to just post the equation.
But the equation,
yeah.
But the equation, it works down to about 20 degrees, and then celestial refraction kicks in.
All right, so the values I'm gonna ask for you are both above 20 degrees. So
let me post it real quick and look at it. But I ain't got time. I'm gonna have to come back. But I'll post that for you real quick.
All right.
Yeah.
I think the food I ordered is on the way, so I'll be right back.
$99 plus 99 is. Oh, my bad. I have my mic open. I'm trying to read what someone wrote here. It's some weird shit. Some weird math shit. Anyway, what are you guys talking about?
Sextant.
Yeah, with this flat Earth math for sextant.
Oh. Yeah, I saw this before.
I heard it first today. There was a guy in Gems talking about how he was a flat earther for the last 4 years, but now he's not.
Oh, ooh.
That was weird.
Who was it?
Sean
G?
something? Yeah,
Sean G.
Sean G.
Oh,
Yeah.
Sean G. Oh,
He didn't have some. I mean, he didn't really have very good answers for my questions.
What was wrong?
I asked him. What's that?
Yeah. What was wrong with his answer?
I asked for two specific examples. One example of I guess you could say a flat Earth proof that he fell for, and then another example of what he saw being a flat earther that brought him back to thinking it was a globe. And he didn't provide an answer for either of those. He just said that he didn't really know what he was talking about, that he had seen some documentary about flat Earth and it was all wrong. And I wasn't even really pressing him, because I can tell you right now, if I'm a globe skeptic. I don't think that we live on a globe. I can tell you why I think that, and if I was to be proven wrong, well, then that would be the very first thing I'd be like, oh yeah, this is why I thought this, and this is why I don't think that anymore. He just very, you couldn't even call it topical, because he actually didn't give me an example of any one thing, but it was his choice.
I love all these different labels. Where a globe earther, flat earther, globe skeptic, level earther. It's bizarre.
Well, I like to be accurate with what I'm saying. And flat earther, it just it's not a very good descriptor word.
What's wrong with it?
Flat is not a shape. It actually, to be completely honest, anyone that's looked at the flat Earth and sees that there's something to it, they don't really. Most people don't really have that term. It's the people who are not flat earthers. When they hear the term flat Earth, they think pancake in space, and that just drives me nuts. I don't want to have to go through the whole rigmarole of explaining that I don't have a model. I don't have the answers to a lot of the questions that you think you do have the answers to. You know?
Well, you could say that you are a globe skeptic and blah blah blah, and then you could say that you're a extended planar with topography and flat water, or you could just say flat earther.
Yeah, I don't know. I guess I'm trying to I don't know, trying to change the lingo here.
So if you're a globe skeptic, right? What sort of place do you live on?
Wherever I seem to go, water always finds its equilibrium, static equilibrium, in any container that it's placed in. And I've been told many, many times that we live on a place where 70% of the surface is water. So I'm not, you know, I've never seen a large mass attract a smaller mass. I just go off what I can see, and to me, we're in a place that has meets the characteristics of what I just described. It's like some sort of container that we live in.
So doesn't
I don't see water spilling off the sides.
So doesn't that then put you in the camp of a flat earther?
No, I wouldn't. I think flat earther is a too broad of a term, because you've got people that think in infinite plane. You have people who talk about, the ether, the ice
There's a difference
wall.
between not thinking it's a ball and thinking it is flat. Those are two different things. You can disagree with the suggested idea that it is a ball-shaped thing and not necessarily agree with the ideas that are out there otherwise. You don't have to agree with everything that's not a ball just to disagree with the ball.
Yeah, and I think flat Earth in general has been psyoped. Like a few years ago, you'd say, oh, the counter position of flat Earth would be, the Flat Earth Society, I guess. They're like the gatekeepers. But now I feel like, Flat Earth YouTube personalities are the gatekeepers. It's stopping people from asking real questions. Like, I don't want somebody to just throw a picture of a blue marble at me, throw a picture of space and say, oh, space is real. Just like I'm not going to throw a picture of a fucking oil rig or a tanker or something and say, oh, look, the Earth is flat. Like, there's another way to do this. The technology will soon be here for us to, really prove definitively one way or another. And I feel that just with the history of, the powers that be and the history of mass psychosis and psychological operations, I would, if I was a betting man, I would say that we don't live on a globe, and there's some really weird shit going on.
What technology are you talking about that will soon be here to make it definitive?
Sorry, not that it's not already here, but it'll be available for civilians. Notice that they had to like really clamp down on drones really quick, and make it so that everybody has to have a private license. There's all sorts of restricted airspace. Sorry, not private license, pilot's license to operate them. There's all kinds of restricted airspace. They need to control, and I know you could just say it's for safety reasons. Obviously we don't want an airplane hitting a drone, but I just think that the technology that is available will soon be advanced enough to the point where we can get some really nice shots from hundreds of thousands of feet up in the air. We should be able, like, I don't want to argue with somebody about, oh, it's a fisheye lens or not. Like, I just want to get my own camera that I know isn't a fisheye lens, get it to 120,000 feet, and just see for myself, really.
But even going up 120,000 feet isn't definitive many
I think
times.
from the curvature that from the videos that where they say that you are seeing curvature and it's clearly a fisheye lens, a lot of those are taken between 75 and 120,000 feet, those weather balloons. And I mean, those numbers are an approximation, but I mean, most of the videos, I'm pretty sure those are like the altitudes. And so, yeah, I don't know. I think it'll be there for you to see. If it's there, if it's curved, then without a fisheye lens, I'll definitely see curvature, right? If it's not, definitely won't.
So do you have
I
to
mean,
do it for yourself? Because there's plenty of footage out there from high altitudes already that show things. Is that not definitive enough for you? The imagery.
it is definitive. It is definitive enough for me, but
Yeah.
it's not genuine for me to say, oh, I've done this experiment, I've made this observation. I haven't made that observation. So that's why I'd want to do it for myself, because you can go on YouTube right now, type in high altitude Earth curvature, and you'll get plenty of videos of, say, there's one where there's a camera attached to a MiG, and you can see Earth
Yeah.
curvature at like 60 feet altitude from the fisheye lens, and it's like, this is obviously not that. This
But
is
see
fake.
that argument to me, it doesn't really hold much water. That's like you telling me that you live in the United States, and I go, well, I haven't been to the United States, so I don't believe it's real.
You must have misunderstood me, because
I may have.
yeah, I know. I'm just talking about how, okay, YouTube censors flat Earth videos, right?
Yeah.
We can agree on that. Okay. Don't you think that they should censor, if they're going, well, should or shouldn't? They make up their own rules. But
Yeah.
in a perfect world, if they were going to censor something that they legitimately thought to be incorrect, well, there are quote unquote high altitude Earth curvature proof videos that are incorrect. They're just being filmed with a fisheye lens, and you can't definitively say one way or another that curvature is there.
Yeah.
So they should take those videos down too, but they don't. They let them, gather hundreds of thousands of views.
Interesting.
I mean, if we're going to be intellectually honest, and by we I mean if YouTube is, I would remove those. I don't see the need. If it's friggin' curved, it's friggin' curved. You don't need fake videos up there. That's why, like, the blue marble photos, all the images of Earth that are photoshopped because NASA admits they have to be. It's so disappointing. I got my new phone today, the iPhone 13, due for an update. I haven't had a new phone in like 4 years. This technology, I've got like 100 times the tech that I would need to go to the moon in '69, right? Like, I don't know. They went up to the moon with some tinfoil and a CD player or something. So I should be set. I'm gonna pop into the store real quick here. So I'm gonna
Saw an interesting thing in Brian's video there
Okay.
about the inferior mirage being caused by a hot, less dense air being below colder, more denser air above. So if relative density is the cause for objects moving up and down, then if you have an inferior mirage, things should rise there towards the more dense medium above.
That is interesting.
It's not interesting, it's just rhetoric.
What are you doing, Travis?
To get your connection fixed.
Yeah, I know.
It's back in his big truck, too. That's good to see.
You've been off of work, Travis?
I think he's
No,
just been gallivanting around California playing is what he's been doing.
no, I've been back at work since the end of the year. I just haven't been online a lot.
I mean, you've done a lot of observations, Travis. Do you think that Brian has something with his formula? Or equation, rather?
I'm sorry, my connection here in Virginia is horrible.
Oh, okay. It's weird for me that some people somewhere have a bad connection because, I mean, the coverage over here in Finland is almost 100%. Just used to that you always have good coverage. I'm gonna get back to Brian's video.
Yeah, I was kind of hoping to see the interaction with Brian and Bacon, see how that panned out.
Yep. I'm just trying to see how many assumptions Brian is making with these equations. Did Brian say that he'll be back?
I assume he was going to be.
I'll be back.
Oh,
He'll be back.
nice.
Mailman, do you have any hard data to go with your rhetoric?
Which rhetoric?
Well, the rhetoric that you just gave us in terms of what you think creates inferior mirages.
Not my rhetoric. That's what was in Brian's video.
That was Brian's rhetoric.
Yeah, not mine.
Right, but right. So if you give us a citation, all it's going to do is give us rhetoric. It's not going to give us any data.
Yep, and I'm just looking for data from Brian because he gave us a video.
Okay, but listen, yeah, but I'm talking to you right now. You just gave us a pretty big mouthful of what you think inferior mirages are caused by.
No, oh no, I don't claim that. That is in Brian's video. I'm talking about Brian's video.
Okay, so you're quoting from Brian's source?
Yeah, there was 3 links in the video. There's one from Finland, from the meteorological office from Finland, and then 2 other ones. I think it was Britannica.com or something. Was talking about thermal inversion.
As far as I've looked at, I think the thermal inversion is just rhetoric. I think they just describe what they think is happening.
I think you can measure thermal inversion.
Right. I've never seen anybody show any measurements.
Yeah, I don't know about that. I mean, I haven't measured it. Obviously, a hot road is hotter than the air, and if it releases heat to the air, then sure, there is warmer air below and colder above, but the density is mixed.
Yeah, but that's, again, you're just guessing, right? Like how far above the road?
Yeah, I haven't made any measurements myself. Neither has Brian.
No, I mean, I think that that's fair. I'm being critical of people like Andrew Thomas Young and others that, you know, when I read these articles, all they do is describe inversions and steep inversions and severe refraction with no data at all. And it's just absolutely frustrating.
Sure, fair enough. That's what I'm actually doing with Brian now.
Just make sure it goes both ways.
Sure. I mean, yeah.
Because I'm hard with Brian too. When he says things, I'll say I don't agree with what you're saying right now, because it's just this description of what is seen, and I can do that, right? I can describe what I see.
I've seen you do that too, Flat Earthers, yes. That's what I don't. I mean, I don't believe in the globe because of just looking at the horizon.
Well, that might be a little bit of the opposite for me. I believe the Earth is not a globe because I can make assessments of the horizon.
You can do what?
Make assessments of the horizon.
Ah, okay, yeah. I think I can sort of do the same, but I don't tend to use it that much. It was actually interesting when I was listening to Mr. Sensible at Bev's, and Bev said, knowing he's like he knows, or I thinks he knows a lot about geometry, and he said that the sextant argument is moot because obviously you can get an angle from anywhere. I'd like to see Bev go to Nathan to talk about sextants.
Well, can you say that again?
Yeah, Bev said that you can get an angle from anywhere. You don't. The surface is irrelevant because you can go to a mountain top and measure an angle to whatever you want.
No, Bev says you can do fuck all with an angle.
Yep.
He's right. He's
He
right.
says
You
you
need other information to go with it.
No. Well, sure. You sort of need some other information, but you can do things with an angle.
Hey, I'll say this about the inversion and all that. That came from Dr. John D. That came from Dr. John D. I think he has a little bit of data, but not the kind that I think we're looking for. I don't think.
I think the worst problem for the flat Earth when using the sextant is that if you use just the GP distances, you can no longer map that to a flat surface. It doesn't even matter how you're taking the angles.
Look, hopefully I won't have to say this over and over, but 60 miles per degree is not exclusive to a globe. It's empirical. It's reality. Whatever.
I don't think you got the point, Ben.
Whatever is causing it, whether it be a celestial sphere, whether it be Earth curve, whether it be traction, whether it be perspective, it's not exclusive to a globe. I understand.
Let me just repeat myself because I don't think you understood.
I understand the geometry.
No,
okay?
no.
I understand that.
What was my point? What was my point? I just said. What was the point I just made? Because what you're saying is irrelevant to what I just said. I don't think you understood it. What I'm saying is, just the GP distances alone already prevent you from mapping those distances onto a flat surface. This is completely independent from how you're getting those distances.
You got it exactly backwards. That would prevent you from mapping it on a globe. Okay?
Of course not.
Okay,
I
wait a
can
minute.
give you examples.
Now, wait, hold on. Let me finish. Okay, now if I have an angle of equal altitude, okay, so let's say I'm 20 miles or 20 degrees from a star. Okay, on a flat Earth, I could make a circle around that star and maintain 20 degrees and create an angle of equal altitude, right?
The circle of the circle of equal altitude.
Yeah, I can pretty much do a circle on a flat plane to a star 20 degrees. I could do a big circle around it and create. Yeah. Okay, now you can't do that on a globe. Okay.
Of course you can.
Not of equal altitude.
Yeah, the circle you're gonna make on the globe is every point on the surface of the globe that has that angle, that same angle to that star.
You have to shave a portion of your globe off for it to be equal altitude.
No, because the circle that you're making, why would I need to shave it? Because this doesn't have to apply for the inside of the circle, not for the outside. You only have
elevation. Let me explain better so you know what you're arguing. Equal elevation. Take a ring, okay, about the size of like let's say about twice the size of a milk carton. I mean, shit. How about the size?
Let's do it on Blender right now.
Hold on. A hockey puck. Just take a ring the size of a hockey puck. Okay. Now draw your circle around on your globe. Now set that ring down on your globe. Okay. Where could you put that ring? Where it's equal elevation, anywhere, nowhere. You can't. It don't work, bud.
Let's see if I can't. I'm gonna open Blender so we can try to do it right now, right? What do you say?
Yeah.
Yeah, let me get my mouse. One sec. Yeah, 1 second. I'll just get my mouse.
Okay. And what you're gonna have to do is you're gonna have to chop off a slice of that globe. The only way you can get equal elevation is by chopping into the globe. You can't get equal elevation with a ring on a ball. Think about it. You're wasting your time even opening Blender.
I'm back. Let me.
Yeah, it's me.
Share my screen so we can all do it together. Right? Can you see the Blender live stream?
I can see it.
All right.
Hold on. I don't see it.
Let me add this sphere. Make it a bit more smooth than this. Too late.
And it's gone.
I guess
it's right here.
I can see it. Oh, you mean this sphere?
Right. You all see it?
I can see it. I don't know about them.
Oh, I see it.
I see it. Yeah.
Right.
I see it.
Beautiful.
And what I want you to do, don't just do one either. Do three.
Sure. 3 spheres?
No, 3 circles of equal altitude.
Okay, just pick a point on the surface in a direction. I'll show you. So let me just add a random point here, right? Let me see. What do you think about picking this point and just creating a random line like this? Is this good enough for you? This direction here?
Fine. Yeah, just anything between like about 30 and 80 degrees. Just pick a few of them.
Alright. Wait, I'm not sure what angle is this. But I can just let me get my keyboard because the one I'm using right now doesn't have numpad numbers, so I can't align my view. 1 sec. Alright, so let me align it with one of the lines here. Make a couple of rotations.
You're gonna need R for that. No, just kidding.
Sorry.
I said you're gonna need R for that.
Yeah, it seems pretty aligned. It's right there. Right, so I aligned with my x-axis. No,
tell me your
my
angles. I want you to tell me your angles.
Oh, that's to be hard to do.
That's a problem,
Right.
ain't it?
No, that's not a problem. I just have to establish
Okay,
the
good,
horizontal here.
good. Okay. I need the angles too.
All right.
Yeah, no rush.
We'll get
Let
there.
me
We'll get there.
add a plane here. And make it adjacent to the surface. Right here where the line touches it.
No, I want your angle from the observer.
Yeah, that's where the observer is. Observer is.
All right.
Observer is right here, where all of this touches. Right, that's the observer, and this plane is the horizon, or the horizontal of the observer, right? And that's the direction of what he's looking at. You get that?
Okay. Give
What's
give us the three angles, man, and let's get your angles equal altitude. But no rush, man. I know it's gonna take a second.
Yeah, so this line right here, if I just align a cylinder with this line here, everywhere where the cylinder touches the sphere is going to have the same angle to their own horizontals, which is
So you got two
exactly.
tangents. So you have more than one tangent point, and you must have. If every spot is going to be the same, then wouldn't you have more than one tangent?
What are you talking about? Every point has its own horizontal. Every horizontal is tangent to the surface.
What do you mean a point?
So you have 10,000.
Yeah, but you just said multiple points.
Yeah, which makes a circle. Doesn't
That
a
means
circle?
multiple tangents, bro. If you have multiple points, and you have multiple tangents. That's problem number one.
Why? I'm referring to a circle on the surface. Every point on the circle. Every point on the circle is going to have the same angle to this line right here.
You can't have multiple tangents on a sphere, bro.
Why not?
Because it only touches one point.
If I just rotate this around, for example, let me give an example. If I rotate this plane around, it's always adjacent to the surface, always. So all the circle that this plane is doing, all of those points in which this plane just touches the sphere, is going to have the same angle to the direction of this line. And someone is
hot micing.
So, yeah, someone's hot micing.
In fact, you could show that there's multiple tangents by just copy and pasting that and just on another part of the
Well, if I want to make a
somebody's hot micing. Somebody's hot micing. Somebody needs to go on mute.
Yeah, it's banned. It's banned. All right, thanks. Maybe someone muted Mailman mistakenly. Anyway, let me make it more clear here, and add a cylinder, right?
Yeah.
Let me make it very precise.
I've got no problem with it on a cylinder, bud. It's the sphere part that I'm beefing with.
What part?
It's set up on a cylinder for your globe, for your Mercator. When you use a sextant with the Mercator, it's based on a cylinder.
The Mercator? Why would you use the Mercator?
What map do you use when you're using a sextant? When you're out at sea, what map do you use?
I use a globe.
Now you take a globe out to sea with you, do you?
No, you don't need to. You just use the coordinates, because you have three coordinates. You have three coordinates. And you know your distance to those three coordinates, and you use spherical geometry to work out your coordinate in a sphere that matches those the three distance to the three coordinates. You don't need a map. That's not that the map will only work for a very small, very small surface.
I'm good with
So
that,
if
man.
your surface is small enough,
Aren't you making some assumptions there, man? Would you be honest and admit that you're making some pretty big assumptions with all that?
what assumptions? I'm explaining how it's actually
You're assuming that the
used.
stars are trillions and quadrillions of miles away, for one, right?
They're far enough that we can't see parallax with the naked eye.
And you're assuming that
That's all it takes.
all the rays are parallel.
Yeah, but hold on, just real quick. That's an assumption you can't prove.
No, that's part of the model. I'm testing the model. Of course,
No.
every hypothesis brings a set of assumptions, and when you're testing a hypothesis, you're testing those assumptions. You can't prove the assumptions of a hypothesis before you even test the hypothesis. Otherwise, what would be the point of testing the hypothesis, right?
No, you have to. I would say you have to have certain variables that you do know. Simply because, hold on. Simply because you have parallax with trees on the Earth, and you look up into the sky, and you can't detect parallax with stars, it doesn't mean that you push the stars so far away that they escape the physics of the world.
I'm not saying that.
Yeah,
Wait,
you
why
are.
did you bring up trees?
No.
Why did-
What I'm
hold
just
on,
saying.
hold on. Why did he bring up trees for?
Okay.
I want to hear. Yeah,
Okay.
tell me, why did you bring up trees?
All right. He said you don't have parallax with stars, so they have to be.
No, not with naked eye. Not with the naked eye.
So go on.
Okay. Right. What makes you think you should have parallax with stars at all?
I'm not saying that. I'm not using that as an argument. What I'm saying is, the stars don't see.
You
I'm so
okay?
confused
Listen.
Why did he bring up
If you
trees now?
okay, you just said I'm not saying that, but you are appealing to parallax.
No. I'm saying we don't detect parallax. I'm not saying that therefore they're very far.
You're just like Rumpus. Rumpus says we don't have 1,000-mile-an-hour wind at the equator, therefore the atmosphere is stuck to the Earth.
That's not my argument. So I mean, let's stick to if.
There's no reason to appeal to parallax at all. Leave it out. Don't talk about it.
I'm not appealing for it. What I'm saying is, we are using, when we're using the sextant, right? The light from stars are parallel enough that
parallel. You see parallel light.
Sorry.
You see parallel light.
What do you mean?
You said it, not me. You said parallel light. What the fuck is that?
Yeah, the light from stars seem to come in parallel. Very close to parallel.
Can you show that to me, please? Because I don't see parallel light.
Yeah, the sextant working shows that they come in parallel. If they came from a single source, right? You wouldn't. The way you use the sextant wouldn't work. They come from a close source, and there is parallax. The way we use sextant doesn't work because we wouldn't have the right GPS, so we wouldn't be able to locate ourselves. Sorry?
Of how that doesn't work. If you look at clouds, if you take a cloud that's directly overhead and you drive away from it, when you get about 10 to 15 miles away, that cloud will be like on the tree line. You know, it won't be.
Yeah, I'm not talking about single observation.
We're not talking about clouds. We're talking about stars. There's only 15.
And that's why earlier I was telling
here we go.
That's why earlier I was telling you to look at the airplanes and just study them. Perspective is a very funny thing, dude. You when you look at them planes and you see them way off in the distance, like angling up and towards you, kind of like. I mean, it's hard to even explain. Just take a look at them one day, and I really recommend you do this. And you'll see that the perspective is a very, very fucking funny thing, man. The way it works.
We don't see that with
stars. I'll take it back. And I agree that I'm assuming stars are very far. And that's how I'm testing this hypothesis. So what?
Okay, so here's my question.
And you're assuming a radius. Go ahead.
Hold on.
I'm testing the radius.
Hold on. Keep the stars proximate. Don't remove them.
Well, but then the math, we would need to come up with a different map for the sextant, because that's the assumption.
Right.
That's assumed.
Exactly.
That's
Can I have 10 seconds?
Well,
they're far enough away that the light comes in parallel. We see this. We've observed these 58 stars for at least a couple hundred years.
We don't. Light doesn't come in parallel.
Yes,
it changes.
From each point source, the light comes in parallel.
No, it doesn't.
Here's the thing. Here's the thing. If stars were close and we lived on a flat surface, we would need different math than the one used in the sextant. And this is very easy to point out. This is very easy to visualize.
Man, why? Like I said, you're acting like you triangulated to all your stars. It's not It's empirical. It's not exclusive to a globe. I understand your geometry, okay, by putting the stars at infinite distance, but there could be multiple reasons of how that.
There are infinite distances.
They're just. One example.
How does the section work on the flat Earth, Brian?
Yeah,
Brian, how does the section work on the flat Earth? You haven't explained that. Please explain to me how I use a section on the flat Earth.
He's gonna send you a 20-minute video. But he says he has an equation that works on the flat surface.
No, it doesn't work
right?
on the flat surface.
Yeah, let's check that. Let's check that.
I'm trying to say over 90 times d times point A.
Doesn't work.
Okay. When you get you an angle, there's no assumption. I heard him earlier.
I'm sure it works, but I'm pretty sure he's adding weird shit that we're
No.
I think
no. There's no.
I think he has a sky curve, I believe.
All you're doing is measuring an angle. That's all you're doing. You're out at sea. You measure an angle. You triangulate the distance, and you apply the fucking formula.
No, you don't
triangulate.
No. Let's see if that works. Can we do it? Can we do it right now?
Brian,
we can try to do it right now.
You trilaterate for your circle of equal altitude or circle of equal distance from the ground position. There's no triangulation involved.
But in your video,
that on a sphere, and he had to revert to a cylinder.
But
the cylinder is only being used.
There's
One sec.
Points. If you're putting multiple points on a globe, then you're putting multiple points on it. You can't. That don't work on a globe.
No. Multiple points.
On a globe.
Multiple points. Let me address at least one sentence. Is the multiple points are all the points on the surface that have the same angle to that same direction, which is the circle of equal altitude. And this wait. And all of those points form a circle on the sphere.
You just agreed before we even started that if you do a circle 20 degrees around the star, then you're going to have a circle of equal altitude. You just agreed to that. So what?
Which is this circle right here? This circle right here. It's on the sphere, and it has equal altitude to that direction.
So now you have 1 point.
Yeah. And I know this point is somewhere on this circumference.
Show us the angle.
Sorry?
You measure the angle.
Yeah, alright, if you want me to check what angle is this one, let me try to do it by hand. 1 sec.
Brian, you're talking about triangulation. Is it a triangle with 3 straight lines?
Well, he's trying to it is a triangle with 3 straight sides. He's trying to pinpoint triangulation to me.
But your equation.
I want him to do some triangulation. Go ahead. Sorry.
But your equation, does it bend one of those sides?
Absolutely not.
Absolutely.
Yeah, it's about 25.5. That's roughly this angle right here.
What do you mean about? You're in Blender. I want an exact angle.
Yeah, I'm not sure how to calculate angles in Blender. What I'm doing is I'm rotating this until it fits the line.
I won't give it to you, bro.
Yeah.
Don't you find that funny? Don't you find that suspicious that you're having to guesstimate the fucking angle? Excuse my language.
Yeah, because I'm using. Yeah, I mean that's just a lack of. Just don't know enough about Blender.
Get an angle with a curved adjacent.
Yeah, I can. It's curved adjacent. What is curved adjacent?
Not without a bunch of assumptions, man.
Oh man.
What the hell is a curved adjacent? What the hell are you talking about? Who's using a curved adjacent here?
It's your baseline. Why do you think it won't give you the angle, man? Because your baseline is curved.
I'm giving you the angle. I can give you with more decimals if you want to.
Yeah,
not without major assumptions, man.
There's
what major assumption? He literally
the
measured it.
assumptions. Yeah, the assumptions are the ones being
Why is NASA
tested.
just butting in every 2 seconds to just like he's the hype man in the background?
Sorry?
What, me?
What?
I think he's talking about me.
Oh,
No,
sorry.
How can you?
Sorry about that. I
How
thought
can
that was
your
me.
how can your equation not bend one of those sides of the triangle? What does your equation do to the
Let's
triangle?
test the equation. What's the equation? Let's test the equation.
It's 90 minus A over 90 times D times A. D is the
Okay, one
triangulated
second.
distance from the angle. So if you say you're out at sea and you measure 30 degrees, okay? So based on 3959 is the height to your star. We're at Polaris in
How
this
do you know that?
instance.
How do you know that?
Because 1 mile, 69 miles, Polaris drops 1 degree. Okay, that's in reality.
That's not necessary. That's not necessary.
That's on top of the ground. That's not
Oh my
down to
God,
the
that's the
center
curvature
of
of the Earth, you idiot.
That's what we measure in
You're
real life.
conflating.
Man.
You're conflating.
Hey.
No. So the
No,
I'm
altitude
not
of Polaris
complaining,
changes.
bro.
NASA.
So what? The altitude of
Nessa,
Polaris
the-
changes.
Let me finish this statement one time. If you
Nessa.
travel 60 nautical miles in reality on top of the ground,
Oh,
then
God.
it'll drop 1 degree. That triangulates to 3958.7, your exact radius, but it's on top of the ground. That's what's empirical. You took and moved it to the center. You put it under your feet. But in reality, we measure that on top of the ground.
So Polaris is the altitude to Polaris changes depending on your latitude.
No, it doesn't.
Well, then how do you know it's 39? Where's the 3959 to?
It's
Only-
one. Oh my God.
NASA. Let me just put this equation to the test.
Yeah,
Let us just. Yeah,
look at it. Look at it.
All right. What's the equation? Can you type on
Okay, so we're out
live
at
stream
sea.
text?
We measure an angle of 30 degrees. And
Can you type it?
So now you're gonna go. You could do the math, or I just go in the triangle calculator and put your angle for 30 degrees, and put your height for 3958.
I'm not understanding it. Can you type the equation?
I could type.
Oh, exactly. What exactly?
It's 90
What
minus
exactly?
A. Not
One
A is the
second,
angle. D is, listen. A is the angle. D is the distance. So 90 minus A over 90. Okay, you got it? So whatever angle you measure, subtract that from 90 and divide that, whatever you get, by 90. Okay, so
All right.
90 minus A over 90 times D. So then you got to triangulate that. So that's times D times point A.
Wait. Where does this D come from? What is this D?
That's the distance. Then you got to triangulate.
What is this D?
That 30
Listen
degree
to.
angle,
Stop,
you got to
stop.
triangulate it. Listen, if you go to
Slower,
triangle
slower.
calculus, let me explain.
You want me to understand or not? Because you're going non-stop. I need to clarify some things.
Bro, you
Let's
asked me
go.
a question and then you're blurting out retarded shit. You want me to answer your question or not? You said,
Yeah,
where's the
that's
distance come from? Let me answer. Triangulate the distance with 3958 as your height, as your opposite side. Okay, go to a 90-degree right triangle calculator or do it by hand. Okay,
Mhm.
put in 30 degrees and put in 3958. It'll give you a baseline distance. That's your D.
Put in 30 degrees. Or
There's
you
no
mean if
assumptions in this equation.
I'm trying to understand. Okay. Let's do the thing. I'll open GIMP, right? It's a software so I can draw, and then let's go slower. So I'm sure I'm not gonna miss anything about your equation, right? 1 second. I'm just opening it. All right. Okay, so here I have a straight line, right? I have an observer here. That's me.
Okay,
And I have
30 degree angle.
A star here, right?
We'll start with a 30-degree angle.
Yeah, I see the star with the. Is this the 30-degree angle?
Right, yeah.
Is this
Yeah,
the-
that's 30
all
degree
right,
angle. Okay, now your opposite side, your opposite to your is to theta is 3958.
Oh, here's 1 second. 3958.
No, 3958.
Oh, sorry. This is this height, right? So it's the height of the sky, right?
Right. Now,
okay.
Triangulate. Now triangulate to get your baseline.
Okay, so it's going to be, I mean, the tangent of 30. Oh, I'm really bad at writing with the mouse. So this angle here, let's call it alpha, right, instead of 30.
Man.
No, I mean, let's build the equation here, which is so you can get a. So the tangent times this distance here is going to be 39.58, right? Which means that to get D, I just have to divide this by the tangent.
That's wrong.
Is it wrong? Isn't tangent this side of the triangle divided by this side of the triangle? If I time my tangent, the tangent is the slope of this line, right? So if I time that to x, I get 1, right? So I'm just timing that to the distance to get a height, right? What's wrong with this?
Oh, let me figure this out. My brain is dookie right now.
Yeah, tangent is the slope of this line here. So the slope times delta x equals delta y. This is delta y. Sorry?
I don't think you ever learned Sakatoa.
What's Sakatoa?
Oh yeah, Sakatoa. Yeah, it would be opposite over adjacent if it's in tangent.
Dude, I have learned Sakatoa, and I guarantee you, Pay don't know what it is because he didn't even understand that 39.58. Pay, what's the sine of 30?
Well, knowing signs from the top of the head doesn't mean knowing what it means.
Shit. If he knows Sakatoa, Paid, what's the sine of 30? Paid. Paid, how many radians are in 1 degree, Paid? He's going to accuse me of fucking not knowing Sakatoa. I promise you, he don't understand any of this shit. He'll look it up and come back with a fucking answer, but it's going to take a minute because he's got to look it up. He don't know any of this shit. So stay out of it, Paid. Anyway, I'm about to post the fucking calculation for you, okay?
So this is where the distance comes from, right? According to you.
It's 68.55, man.
Yeah, but this is the formula, right? To the distance. This formula does make sense for a flat Earth, but this formula is not how people use a sextant.
What are you talking about, dude? You're fucking triangulating, dude. You can't get past a simple triangulation of an angle, bro. If you can't get past a simple triangulation of an angle, bro, I can't help you.
There is no triangulation involved in celestial navigation. It's trilaterate.
Can I finish a sentence? So the problem with this is that when you're using a sextant, when people are getting the distance to the GP of the stars, they don't use this formula here. They use this formula here. They get 90, right? Minus the angle, and they time that to 60 nautical miles. That's the formula that people actually use. So this is the formula that works, which doesn't give the same values.
Listen, this is not just for a sextant, man. This is
But it doesn't work. It doesn't work even.
Ratio.
It doesn't work.
Just show, bro. I didn't cut you off, man. Let me explain. It's just a ratio explaining how it works on a flat plane. How refraction or perspective, whatever.
Which is not how it actually is being used. All right. Do you know anyone? Do you know anyone who have located themselves using this equation for distance?
Well, you started this whole thing off asking how it work. We make it how it works on a flat Earth. I'm just showing you how. In my model, that's all it takes is a simple fucking equation to work out the angles.
Okay? Yeah, of course. When I said it,
it's a function of perspective and refraction.
Yeah, this formula does make sense, and this formula isn't compatible to how the sextant is being used. So if you want to argue that this can also work, even though it gives different values than the ones people actually use, Well, that's an entirely separate conversation.
Hey, listen, there's
because-
a couple numbers that are off by a few miles. So if you go, if you travel 3,000 miles, you could prove me wrong, but you'd have to go about 3,100 miles and prove that instead of or you'd have to go almost 4,000 miles and prove to me that instead of 39.58, then it would be like 39.51. Okay, so you have to,
check?
that's the one that's off. It's 45 degrees. You'd have to travel 4,000 miles and distinguish that 7 miles to prove me wrong.
Okay, wait. Let me just get something. So you said you used the Mercator map, right, to make the triangulations. Is that correct?
No, I'm saying with a sextant in the almanac, it transfers to a Mercator map.
No,
you're saying that you bring a globe out to sea, which is goddamn big.
No. I didn't say use a physical globe. You ask it what map do I use to get the distance. Well, actually, I'm using the globe. I'm just not using paper. I'm not using it physically. I'm using it mathematically, because when I know the three distances to three spherical coordinates, there's a way to triangulate a fourth point on that same sphere that matches those three distances. That's the formula people actually use when they are getting their position using sextants. And the distance that they get to the GPs isn't this one. It's this one.
Well, in my defense, I'm not making any assumptions, man. In your model, you're making all kinds of assumptions. You're knocking mine, and I'm making zero assumptions.
And also, you're not testing it. We can use the map you think is
39.59 to the stars.
But that's irrelevant.
Once again,
it's irrelevant.
It is relevant.
Let me respond to Paige.
He's conflating.
Let me respond to Paige real quick.
Okay, doesn't mean the model is wrong.
That I assume 39.59. Once again, in real life, Paige, in real life, you can go 1 degree. I mean, you go 60 nautical miles and see a 1 degree change on top of the ground, Paige, not from the center of the earth, from on top of the ground.
Oh,
that
let's test it
triangulates
right
out.
now.
Let me finish, man. That triangulates out to 39.58.7, Paige. Okay,
amazing.
That's not an assumption,
That's
Paige.
also the curvature of the Earth measured.
What the assumption is moving that down to the center of the Earth. That's the assumption, Paige.
No, that's not an assumption. That's measured.
Yes, it is an assumption, because that's what we triangulate on top of the ground.
Yeah,
on
because
top of a
that's
flat
what the
plane.
Earth is curved like.
No, that's what we get triangulating from a flat plane, Paige.
Yeah, because it's not flat though. You can measure it. We'll get into that later. You're conflating.
No, let's get into it now. How are you measuring it, Paige?
He's talking celestial nav tonight.
This guy at least admitted that he's making assumptions, but you all of a sudden are going to backtrack the argument. Now you're
making assumptions too. You made assumptions.
Well, I'd like to see how you measure it.
39.59 to the stars.
You've been discussing trying to measure this for a couple years, and you haven't thrown up anything yet. So all of a sudden, you have a way we can measure it.
Go on and do it. Come on, go to the Artaxis experiment. Go to the Artaxis
wait. Yeah, I just want to. Okay, let's go slower, please.
Because he's not even doing the tangent. He's doing some formula 90 minus theta divided by theta bullshit.
You can.
You're telling me I'm making assumptions because what we triangulate on top of the ground is 39.58.7.
You haven't even touched the section.
He's projecting. You got to interrupt every time I talk, don't you?
Brian,
every time I talk, you got to interrupt me.
Have you ever touched a sextant?
As of recently, yes.
Yeah.
Now listen.
Have you ever used
that? That's not.
Listen to me.
Paige, that's not relevant.
Listen to me.
Yes, it is relevant.
Paige has interrupted me every time I've went to talk. If you don't believe me, rewind this stream. Every time I've spoken, this man has interrupted me. Okay. Now, my point is, he's projecting on me, saying I'm making assumptions to 39.58. He's the one making the assumption, projecting that to the center of a globe, because that's what we triangulate on a flat plane.
No, we've measured the globe several different ways and come up with something pretty close to 39.58 miles. Amazing, isn't it? Then you conflate that and say, oh, the stars must be 39.58 because it sometimes works out. Only you aren't even using tangent. You're using what?
Sometimes it works out.
You're using what?
If you understood the math, you'd understand that 69 miles, 69 miles triangulates out to 39.58.7, bro. 1 degree, 60 nautical miles triangulates to 39.58.7.
Because the Earth is curved. Because the Earth is curved, we've measured it.
So now So now he's talking about because the Earth is curved. So now he's trying to use a
Measured
curved
it.
triangle. No, this works
You have
with a
no
flat
proof.
triangle, Tate.
You have no proof that the stars are 3959 other than you've messed up the fact that the Earth is curved, and you're saying,
I
oh, the
didn't say I have proof of that.
then
All
you're
I said is that it
now you're
triangulates to
interrupting
that.
me. Now you're interrupting me. You're assuming the Earth is flat, therefore the stars must be 3959. All of them are the same, by the way. They're all the same, and they just happen to be. And we don't even. If you use the
How do you
almanac, you would
know?
know. If you know the almanac, you would know that the almanac is a globe-based
So
document.
he just said they're all the same. So tell
You
me
said
two
they're all the
stars
same.
that are the same.
They all have to be at 3959 for your math to work.
Yeah, I really wanted to go back to where the discussion was before, because we don't have to. We don't even have to challenge.
Hey, is there? Hold on, guys. Is there no moderator to moderate Wade?
I'm just going to say, let
moderate me, huh?
let Bacon and Brian continue what they were doing, please.
I agree.
Just let them two.
I guess.
Yeah.
Okay, so I guess Brian would deny that every 69 miles we go south, the Polaris drops 1 degree. You have to deny that, right? I don't think you would accept that given your equation. Or do you?
It's empirical. Yeah. That doesn't that doesn't matter what model you're talking about. That's real life empiricism.
Oh, so this doesn't work anymore. let us make a test right now, right?
So wait, would you say that on a flat Earth? Wait, would you at least give me this? Okay, if the Earth were a flat plane, then there'd have to be a reason that there'd have to be something like refraction or perspective to justify the Polaris being 3959, right? And the further you go, I mean, would you at least give me that?
Maybe not around the whole Earth. I mean, if the refraction will have to be different for every place you are.
Let me give you an example, man. If we shined a light through a concave lens, okay, above our heads, a big ass concave lens, or through a pool of water, okay. I'm starting to lose my voice because of that. But you'd agree that it wouldn't triangulate out perfect, like you'd agree that you'd have to work the math to adjust it because you wouldn't get the right distances, correct?
Yeah. But you were saying this works.
You wouldn't have to have any proof of this big ass glass lens, would you?
Let's use okay, if we use 90 here, right? Tangent of 90 is infinite. So this would equal 0, which means you're right below the star, which makes sense. So you have 90 degrees from the horizon to the star, right?
Yeah, there's no refraction at 90 degrees.
All right. So let's.
Great, all I'm gonna be able to do is listen. I'm losing my.
So let's move. So now let's move enough. So our tangent here is to 1 degree, right? So it's 3958 over tangent of 1 degree. Let's see what that equals to. Let me take some notes here. So for angle alpha, right, we have 0 miles to the GP. 0 miles. I'm sorry about my bad writing. Now, I'm sorry, I forgot the 90 here. So if we have the alpha be 90, we have 0 miles. So what if we have 89 degrees? Let's use 89 degrees. Pretty low reflection still. Let's see how far we are from the star. So let me do some calculation right here. I'm going to use a calculator, so we're not going to see it. But it's 3958. This 3958 is miles, right?
Yeah.
Divided by the tangent of 89. To use radians, I have to divide by 180 and time multiply by pi. So I get 59 miles. Pretty still working for now. So the first degree, it works. Alright. Now let's drop more than 30 degrees, right? So let's see if we use 59 degrees. That should equal to 30 times this, right? 31 times this, correct? Let me see how much you get. This angle here is 31 degrees from 90, right? So if I drop every degree I drop, I get an extra 69 miles. If I drop more 30 degrees, then I should be 30 times this further from this angle, right? But because from here to here, it dropped 30 degrees, so it should drop 30 times this amount.
What I'm
according to observation.
Man, I'm really losing my fucking voice, dude. I'm gonna have to draw something out for you and post it for you, man, to try and save time. You're gonna watch like a whole damn video. I agree. I need to make a video to shrink it down, just going straight to the equations and stuff.
All right, I'm just checking some numbers here. So this uses your formula to get from the angle to the distance to Polaris, right? And yeah, so this is a linear relation. So we know to be a linear relation. We know that every degree increases 69 miles. So if I drop 31 degrees, it should be 31 times as further. So this number should be 31 times 69. Let's check it.
It's not gonna be right, dude. You're not doing it quite right. I'm gonna draw it out and I'll post it.
All right.
What do you mean he's not doing it right? You agreed to this formula, the tangent.
Yeah, but I'm comparing the tangent to what we know from observation.
You can say the tangent. Where are you getting the tangent?
He's doing the math for you.
Paid. Answer this question. Where are you getting a tangent?
How do you think you find this angle here, this distance here on the adjacent?
Yeah.
When you know the height or the opposite, you use the tangent. Sakatoa.
Yeah, I'm getting D from alpha and the height of the rectangle triangle. The tangent is what I use to get this value here, the base of the triangle.
You can get the tangent using Sakatoa, but you don't need necessarily. Okay, so and with sine equals opposite over hypotenuse, where's the tangent in that, Paige?
Yeah, but I don't know the hypotenuse.
Opposite over adjacent. We don't know the hypotenuse. We know the opposite. We know the height.
I'm
asking
you.
Opposite. 3959.
So sine equals opposite over hypotenuse. Where's the tangent in that, Paige?
Tangent equals what? Sakatoa. Tangent equals opposite over adjacent.
No, yeah, exactly. I'm not trying to figure out the tangent. I got a ratio. What I got's a ratio here.
So wait a minute. This is your basic math. The tangent will equal the opposite, in this case 3959, over your distance. And then
he wants
3959, the height divided by the tangent.
So this is the hypotenuse. Okay, wait.
What do you mean you don't want to use math? This is the math.
I'm going to get paid the tangent, the opposite, and the hypotenuse, and the adjacent.
About the hypotenuse. You'll give me
they're
all
going to
three?
be different, Paige. They're all going to be different.
Well, they'll all be different. But they should all fit these formulas. If they don't, you've done something wrong.
You're making assumptions that you don't need.
No, we're not making assumptions. This is you in triangles. Do you remember triangles? A squared plus B squared equals C squared?
Yeah, where's your tangent in that, Paige?
The tangent is the opposite over the adjacent. Sakatoa, remember?
So you have to have the tangent then, right?
What do you mean have to have? The tangent can be calculated
You're
quite easily.
forcing a tangent on me, bro.
Yeah, because that's your math.
So where's the tangent in A squared plus B squared equals C squared?
Tangent equals opposite over
There
adjacent.
is no tangent in that.
Yes, there is.
Wait, stop. What's your formula to get this D using alpha and this value here?
He's got some crazy formula that
let's see what it is.
It's not crazy, dude. I'm gonna post it.
Yeah, but this is what it should be.
Because we don't. You're saying that we should use the sine function, right? Because the sine function of 30 times the hypotenuse.
Exactly, dude. Thank you, dude.
Yes, but we don't have the hypotenuse.
We don't know the hypotenuse. All we
But
know.
listen, man.
Actually,
What happens every time Paige gets in the argument? He turns it into a train wreck, dude. And I never get nowhere with the other person. Because Paige,
I'm not putting up with your shit, sir.
Wait.
This is basic triangle math here.
Let's stop. Paid. He is right. We can use the hypotenuse. We can use sine to get the hypotenuse, and then we can use the hypotenuse with cosine if that's what he wants. Right?
He don't understand that, bro. He don't understand that.
It's going to give you the exact same value, but let's do the what he wants.
Times by the sine, then times by the cosine in order to get the tangent. That's what you're gonna do.
He's trying to force a tangent on me, bro. That's what he's trying to do. He's trying to
This is basic math. Do not understand. Do not understand basic truth.
Stop. Please, just stop that. Yeah.
Let's have a conversation.
You don't have to claim that he doesn't know. Let's just use his formula and show what happens. Right. So to get the hypotenuse, right? We have sine of alpha. That times the hypotenuse is going to equal 39.58, right? So the hypotenuse, we just have to divide both sides by sine of alpha to get a formula for the hypotenuse, alright? So far so good? Okay, so now we have the hypotenuse. We can just use the cosine of 30 and times that to h. So this is already h, so we can just time that to the cosine of alpha. So apparently now we have 39.58 times cosine divided by sine, which is equal to the tangent. So this is the same thing. I mean, it's the opposite of the tangent, so it's the same thing as dividing by the tangent. Because the tangent is sine divided by cosine, right? So this formula is exactly the same as this formula. But we can use this calculation if you want to see if we get these same values. So I'm going to do that. Let me stream my calculations also. So there's no trusting anything. I'm still not revealing my name. No. Alright. There's a browser open. I use this as a calculator, so I'm going to create a function here.
I posted something that might help you, man. I posted a picture, dude. But I got to go for a minute, man. But I will be listening.
No problem.
Alright. Let me just define tangent using degrees instead of radians, because that's going to make things easier. So I'm going to use the inbuilt function of tangent, but I have to divide by 180 and times by pi, so I can use angles, degrees instead of radians. Use the same for cosine and same for sine. So let's see, tangent of 0, tangent of 1, tangent of 90. Yeah, it's a pretty large number.
Oh my goodness.
Seems to be working. Let's see the sine of 30. Okay, it's half, right? Yeah. Oh, it's pretty close. Alright, so let's use his formulas. His formula is the what's the value? 39.58 times or divided by sine of alpha, which is, let's use 0. Then times cosine. Let's use 0 as well. Is this how it's supposed to be working? or did I got it the opposite way? Let me see. Okay, let me just do it again. Maybe I did the opposite way. Okay, so sine of 30, or sine of the angle. Yeah, sine, let me check sine of 0. Okay. No, sine of 0.
soon.
Right. Yeah, no, I started with 90, not, I did the wrong, I think it's right, actually. Let me check. 58 times cosine of 90 divided by sine of 90. Yeah, this is pretty close to 0. I mean, it's not very precise, so it's giving me a very small number instead of giving 0. But I'll get that as 0. I'll now use 89 instead of 90. Yeah, I got the same 69. Now let's use 59. Let's see what happens. 2378, 2378, same values. Let's use 20. 10874. Yeah, that's the exact same values as my formula using the tangent. So cosine and sine give the exact same thing as the tangent, as Pei was saying, right?
Wait, so
now?
So you don't need a tangent then, right? Tell Paige that you don't have to use the tangent.
Yeah.
Like he's multiplying the cosine and the sine and coming up. This is just an identity. This cosine divided by the sine is equal to the tangent.
He just showed
Figure
you,
that out
bro.
if you really want to. Remember,
He
Sakatoa
just
figured it out.
showed you, and you still won't admit when you are wrong.
Oh, for fuck's sake! You're basically doing the tangent without the tangent.
Yeah, because the tangent is sine divided by cosine. So if you divide by the tangent, you're using the inverse of the tangent, which is cosine divided by sine, which is this.
Sure.
Those are the same thing.
Sure,
as you can see.
Putting all this emphasis on a tangent, which it really has nothing to do with it. You know, if he wants to put all the emphasis on a tangent, it's the ratio of the angle and the percentage of that ratio is all it is. But I posted that. Hopefully, that thing I posted will help you out, man. But I really gotta back off.
Figure this out. The sine equals opposite over adjacent. Remember SOHCAHTOA? Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. So you divide the sine by the cosine, and guess what you end up with? Opposite over adjacent.
Tangent equals opposite over adjacent. Yeah. Okay, so where is the tangent in sine is opposite over hypotenuse? He just showed you.
You know what a tangent is? I mean, you can do it this way. You can multiply by the sine and divide by the cosine, and guess what? You end up with a tangent. Again, sine is opposite over hypotenuse, divided by a hypotenuse over the adjacent. You end up with opposite over adjacent.
Hey, we have the problem right here. So if we multiply, here we have 20 degrees, right? Which is 70 degrees from 90. So if every degree it drops 69 miles or 16 nautical miles, then from 90 to 20 degrees, it should have dropped 70 times 69 miles, right? But this number is very different from this. So this number right here, if we divide this by 70, it gives us 155 miles. Or if we just divide by 69 miles, what we get is 157 times 69 miles. So this is way far from observation. So if you agree that every
listen, I'll tell you something similar. Where does the sextant start breaking down on on whatever model at about 30 degrees? They say this.
All right, let's do 40 degrees.
Which is 60 degrees on each horizon.
Doesn't break down.
And then where's there no reflection at all?
Even then, you can apply.
Jesus Christ, dude! Really, dude? I'm mustering up my fucking voice to try and say something, and your sorry fat sack of shit ass just can't help but fucking interrupt.
Oh, for fuck's sake! You do nothing but rant.
31. Let's see, 47, 17 miles. How much is that divided by 69 miles? This is 68 times 69 miles. It should be just 50. So it's still very far from the value.
Let me say one more thing before I gotta go. Terrestrial refraction starts kicking in at about 25 degrees or 65, whatever you want to call it.
Yeah, but we're very far from that too. And we already
terrestrial refraction starts kicking in, and and I'm about to release that model, man.
Yeah, but but you have a problem because the right value is 20,760 miles, right? And what your formula suggests
it doesn't matter though. It doesn't matter because listen, you're not putting in the the terrestrial refraction.
40 degrees.
It's 40 degrees.
God damn it, Pate. Hold on. But
you're 40 degrees, damn it.
Is the sextant is not used under 30 degrees. Past 30 degrees.
40 degrees, and you're breaking down by two. You're only 2,000 miles off at 40 degrees.
This 40 degrees is the elevation angle.
Man, can nobody mute Pate, dude? He interrupt every time I go to talk.
You're at 40 degrees. Explain why it doesn't work at 40 degrees. You explain why it doesn't work at 30 degrees, and we're at 40 degrees and it doesn't work.
It's on the dot at 30 degrees. It's on the dot at 40 degrees. What are you talking about?
It's not on the dime. It's not a dime until 30 degrees. That's when you start. You really have to apply it at 15 degrees. And even then, if you don't forget it, you're not that far off. You get worse and worse as you get.
You have a model, okay?
Let Bacon.
You have a model too, and it's not working, sir.
Please.
It works fucking perfect until you get lower to the horizon.
It doesn't work.
Otherwise, you don't understand
40
math.
degrees off the horizon, for fuck's sake, and you're 2,000 miles off.
Because you're doing it wrong, dude.
No, we're not.
You know what? Hear me. Hey, NASA, let Bacon and Brian finish off because Brian's got to go in a minute. So let Bacon and Brian finish it off, please.
Yeah, 40 degrees is still very far from where it starts to give the divergency, and we are already 2,000 miles.
You're doing it wrong, bro. How many times I got to tell you? If you want to hear how to do it properly, you're going to have to listen.
That's the function you provided. This function.
This is
okay, then you're misunderstanding something, okay? Because I've worked it out for every angle.
So you've come up with some. You've come up with some what?
Ad hoc formula. He can't fucking help it, can he? He just can't help it.
You've come up with some ad hoc formula that doesn't work. This is the tangent. It should work.
It's not ad hoc, bro.
Sorry.
It is ad hoc.
Somebody mute Pate.
Oh, my bad. I used the wrong angle there. It's
That's what I'm saying. I was trying to point that out. I was going to say
yeah,
like technically 50.
Yeah. Sorry. My bad.
Yeah.
Yeah, it's just 1,000 miles. I mean, just 1,000 miles.
Arma, it's on the dot.
No, sorry,
100
miles.
When I catch you without Pate in the room, I'll go over it with you, man. But as long as Pate's stupid lying ass is here,
Well, no, but that's the thing. I mean, even with the actual corrected whatever, it's still wrong. But yeah, it's 1,000 off though. But I mean,
100.
100, really?
Yeah. Well, I'm using 69 miles, so times 70 by 69 gives you 4,830.
Wait.
Yeah.
Why times 70 for?
70. Yeah, why am I using 70? Oh, yeah, because I erased the 20-degree angle, but I was still using 70. Well, it's 1 a.m. here, so...
Yeah, you guys are confusing me.
Yeah, that's right. It's 50-50. Yeah.
I was confused at hello.
Yeah, right. Okay, now final answer. It should be... well, it's still some 1,000 miles off. But...
There you go, yeah. I was like wondering, I was like, wait a minute.
Yeah, sorry.
Where are you, in Iceland or something?
Yeah, more than 1,000 miles. Yeah, that's 40 degrees. Let's do 30 just to check. So 30 is 60 off 69, which is supposed to be.
I want Brian to tell me how this is wrong now. Why is it 1,000 miles off, Brian?
For 140.
Yeah, for 140 exactly. And his formula gives
something crazy, probably.
Let's see.
Doesn't matter.
We should use we should use 30, right? In his formula. Yeah, 30.
So it works as long as you stay close to the Arctic Circle.
68 55
Wow.
55 mile, yeah. This is not working out for you, I'm sorry.
Well, if you're down
we're now over.
If you're down
we're now almost we're almost 3,000 miles off using 30 degrees.
If you're down around Florida, you're like 2,000 miles off, 20 2,700 miles off. If you're around New York, you're 1,000. You're 1,300 miles off. So as long as you stay like north of Iceland, you're okay.
I'm going to drop that in the chat if anyone wants to save that somewhere.
Yeah, but
not that this is very that hard to remember, but it might be useful. Oh, we left already.
Yeah.
Well, anyway. So yeah, I think I'm going to drop to bed now.
Alright.
I'm not even being able to subtract 40 and 40 from 90, so I better go. and I did it wrong like 2 or 3 times.
Interesting.
Yeah. Well, good night, everyone.
Yeah, too easy, Bacon. Thanks for trying to demonstrate it.
Alright.
Yeah, I was like trying to point that out when you guys were talking. Like you guys were going loud. I was like, wait, but I couldn't get it in because you guys were just going at it. But yeah.
I'm not quite getting my head around what he's trying to do. Is he trying to account for refraction? Is that what he's trying to do, or
who? What's
Brian?
Brian? Oh, I guess I don't really know. From what I understand, from what he said, he was pretty much saying that on the globe model, we have it where the ground is, curving down, but I guess in his math, it's the sky that's doing like the curving or something. That's what I heard from him. So I mean,
yeah.
Yeah.
Well, all the stars, in order to even begin to work, all the stars have to be at 3959 miles high, which is a very interesting number.
Yeah, I don't know. It's a really weird thing.
And as we just showed, the further you get away from the North Pole, the worse his formula works. He's got some ad hoc formula where he subtracts
that distance
basically makes it work, but
yeah, but
it has
that
no
distance of
groundings in reality. It just is
39.59.
something that makes it work.
That's
based on his false assumption that the stars are 3959 high.
Yeah, but that assumption of 39.59 is when the stars are directly overhead.
Anyway.
Yeah, is that right? Yeah. Can anyone hear me?
Wait, sorry. What? Sorry, I was just blanking out there. Say that again.
No, it's not just overhead, because if it's overhead, the distance is irrelevant because it would just be overhead.
Oh yeah, but you get a degree away from it. I mean, you don't take a celestial shot of directly overhead because your errors are too great.
Real.
You do it wrong.
Okay.
You ain't working. Not even doing it how I described it. That's unbelievable, dude.
That's
It's so
basic
arrogant.
math,
That's so you can't help, dude. The first thing I come back in to say, you got me yelling for no fucking reason, dude. Quit interrupting me, dude. Okay, now that's very arrogant to use my equation, my formula, my model, and tell me it ain't working. Okay, you're obviously doing something wrong, or I wouldn't even have posted this shit. Now, when I have you one-on-one, I'll go over it with you and show you what you're doing wrong. Okay, or maybe I could rephrase. Okay, the thing is it's based on latitudes. Okay, so it works down to the T. It works to the T until you get down closer to the horizon, which is where the sextant breaks down in reality anyway. So that's where celestial refraction comes in. You're applying it wrong. You're missing a step. I'm not even going to bother trying to go over it right now. But if you look what I posted, that picture, and that might help you out. But I'm gonna like I said, when I got you one-on-one, man, I'll go over it with you. Every angle if you want, every single fucking angle. They're spot on, bro.
All right. Yeah, I wanted to real fast. Okay, never mind.
I was just going to say, Brian, your formula that works between 30 and 90 degrees, yeah. But anything under
it works.
30
It works between. Sorry, it works until you get to about 20 degrees on the horizon, or about 20 to 25 degrees. It works from 90 straight overhead, all the way out to about about 4,000 or 5,000 miles.
Right, and that's when the refraction starts kicking in and doing crazy things, yeah.
Yeah, that was celestial. That model's for celestial refraction, but when you get lower to the horizon, that's when terrestrial refraction kicks in. That's the model that's about to come out to complete it. Yes, thank you.
I'm still slightly baffled. How can you have those straight lines at the linear function?
But in my opinion, there's too many assumptions in the globe model. If you
says the guy who's assuming the stars are 3959 without any sort of.
Do you ever talk, dude, without interrupting? I mean, you just wait for me to talk and then you just
like
in?
talk.
That's
though.
But he was talking and you jumped all over him. Go, Brian.
Yeah, so.
Oh, it's you can make the math work, but you have to make assumptions, and but you can't use they're correct when they're saying that you can't have an angle with a curved adjacent. But if you want to try and use the fact that like a bubble level or a bubble sextant, and you're talking some serious inaccuracies, man. You're talking that'll get you like a generalization of where you're at, but it can never get you super accurate, man.
Where's your math? Where is celestial? A over 90 times D times point A.
Can we compare the assumptions made in these both things?
Well, so
the reason, let me try to explain this to them real quick. The reason is you take the 30 degrees and you minus it by 90. So picture 30 degrees latitude on your map. Okay, so that's going to put you about if you're 30 degrees latitude, you're not going to be 30 times 70 miles for simplicity's sake. You're not going to be 2,100 miles away from Polaris if you're at 30 degrees latitude, are you? No.
Yeah.
You're going to be like 4,500, right? So that's why it's inverted. Okay, is to figure it in for latitude. Okay, that's why I say 90 minus A. So you got to subtract it and then apply it. And he might find this useful and where he could correct his where he could correct it. But so you're using the distance from the angle like as used on a map. So like I said, 30 degrees latitude is not 2,100 miles. Okay. Now I know that 30 times 69 is a little over 2,000 miles, right? But that's not the way the latitude works. Okay. So 30 degrees latitude is 60 times 90. I mean 60 times 69 away, right? So it's actually like 4155, I think.
What's the formula again? Is it up here in the A divided by 90 times D times point A?
No. 90 minus A over 90. So if you measure a 30-degree angle, then you divide 60 by 90. Then you multiply that times the triangulated distance.
What's that? Is that height or is that?
So it's going to be 6,000. It's 6,000. Hold on.
How do you figure out the distance?
6,000. Look, it's 6,855 times 0.60.
That's what we're trying to find.
And then you subtract that from the triangulated distance.
How did you come up with 6855?
Triangulated it.
From where?
3958 opposite height. Okay. And a 30-degree angle.
So yeah, that's just straight up trigonometry though. I mean, so but that doesn't check out though. I mean, I don't that doesn't match what we I'm confused here. That's not what we believe to be the case is on Earth. I'm pretty sure it's supposed to be like 4,000. I mean, that's what the globe model predicts.
Yeah. It's 4,000 exactly. So 6,855. But that what you come up with is your refracted amount. So then you subtract that from the 6855. But man, to really explain this, man,
wait,
I don't know, man. I mean, that should be. I wish I
so
could.
hold on. You said. Okay, you first. Well, you first. You finish. Hello.
If you just go to that video and go toward the end, I do it with a few. I do it with a few degrees. You know, I do it right there on paper.
Tangent. You are using a tangent.
You don't have to use the tangent. Why are you putting emphasis on the tangent?
Because 60, the first number you have here on the third line down, the 60 equals 6.855 miles. That's the tangent.
Oh my God, dude.
Then
No,
you
it's not.
subtract from them. Yes, it is. That's how you came up with it.
Dude, who cares?
What do you mean, who cares?
A, you're wrong. Well, I mean, B, why are you putting emphasis on the tangent?
Why are you subtracting 2742 from the tangent? Your distance should be the tangent.
I'm not subtracting nothing from the tangent,
yes, you
dumb fuck, dude.
Look at you.
Dude, you are so fucking stupid, dude.
No, you are, sir. Listen,
it's like talking to a fucking donkey,
I'm using your fucking math, you moron. Listen to me.
Dude, does my math put a tangent anywhere in there?
This bottom line, 60 degrees equals 6.855 miles. That is the tangent.
That is the fucking adjacent, you dipshit. That's not the tangent for the last fucking time. Dude, I can't help this guy.
Hey, I want you to take your calculator right now and punch in the tangent of 60. Punch in the tangent of 60.
Hold on, I'll tell you the tangent. Hold on.
Maybe not.
This is quite a pickle.
Then multiply the tangent of 60 times 3958, and guess what? You come up with that number. Then you make some correction based on what? How do I make this correction? That's the refracted value?
The tangent's 3427, dude. You're wrong.
60 degrees.
Dude, he just says anything, dude. He doesn't understand this. He just says anything.
The tangent of 60 is 1.73. Multiply that times 39.
How can you have a tangent to a degree, bro? So you got a tangent just to a degree?
1.7320508075688777.
Shows you don't understand, bro. Now you're trying to use radians. Dude, you're showing your ignorance, bro. You're demonstrating it to everybody.
I'm not sure what you guys are talking about. I'm just gonna take a step back.
Dude, he's trying to throw y'all off because he don't understand. He's just throwing out bullshit, dude.
Well, okay, real fast. Okay, so you say you get your distance, right? But then you have to subtract the number from that distance to get your true distance. That I don't get. Is that correct?
That's the whole point. The whole point is the formula is like a celestial. It's for like refraction / perspective for a celestial sphere, if you will. But it's basically gives you a refracted value. So you subtract that from your distance to get your true distance, and it works out to 60 nautical miles per degree until you get down close to the horizon.
That's a little sus.
I'm amazed. I'm using your math, and you're calling me a dipshit. I love it.
Bro, where did you get 1.7? You just spit out radians. Then you're trying to claim a tangent to just a degree.
You're doing it, not me, sir.
No nothing, bro.
This is your math, not mine.
Your ignorance, bro.
This is your math, not mine.
Hold on, real fast. Paid NASA isn't necessarily wrong when doing the math.
Can you get tangents to a degree? Just a degree.
I don't know about that part. I just know that when he was doing the math,
okay,
he was doing it right. But I don't know about that part.
Do you think the tangent would be 1.764?
Sir, you are using.
He just claimed that. That's what he just claimed.
He's
in a calculator function.
Math.
He's spitting out some of the values. He don't understand where they go or what they are.
This is your math, sir, not mine. Yours.
Isn't that right?
Bro, you just divided. All you did is divide 30 by 90 by 90.
What I did, sir, listen to me one more time. I just did it for 40. You take the tangent of 40. Tangent.
What's the tangent of 40, Paige?
Oh yeah, 40.
There he goes again with tangents to a degree.
Tangent
40.
It does a thingy. Okay, and then
0.83909. You multiply that.
So
times.
you're using arc tangent.
This is your math, sir, not mine. 39.
Am I using the arc tangent page?
Equals 3,321. That's what you come up with, not me. You come up with this number, not me. This is your math.
That's
you
close.
are using
That's close.
radians,
That's
not
wrong.
me.
That's close. That's wrong.
No, this is your math.
Hold on.
You've done it 3 times. I'm going to do 30 now. 30.
What are you talking about, dude? You're applying my math to your
math.
bullshit, dude.
Right here, where you see the part where it says measured angle, then it has 30, 40, 60. The first number here, you're taking the tangent of 30.
Okay, are you sure?
Yes, I'm counting. I'm doing it right now.
You sure? Even after he showed you the other way to do it.
0.577 times
Dude,
39.
God dang, dude.
58
He just showed you how to fucking get sine, how to get theta, without using a fucking tangent, and you're still
Listen to me, sir.
fucking begging
I don't
it.
give a shit what you're doing. If you don't understand tangents, it's not my problem.
Dude, yeah, I don't understand tangents. Just because you're stuck on a ball, you are applying tangents to the fucking Pythagorean theorem. That makes you retarded, bro.
What
that
are
makes
you talking about,
fucking
you moron?
retarded.
You don't understand. You do not understand. You do not understand trigonometry. You're doing trigonometry and you do not understand it.
Dude, you are so... Oh, my God,
This
dude.
is your math, sir. This is
You do
your
not
math.
understand this shit at all, and you're
This is
projecting your fucking ignorance onto me.
not mine.
Hold on, guys. I'm gonna try moderating this. Okay, so what's the issue? What's the issue we have here? What do we what's going on?
He's doing anything he can to fucking fuck up an otherwise good equation. Anything he can. He's trying to apply a tangent, which is irrelevant. Whether I'm using a tangent or not, I could use a tangent, but I don't have to use a tangent. It's irrelevant.
All right, and now, so what were you saying? What were you doing? Like, what was your motive? I guess.
I'm looking. If you see the little thing you wrote up with celestial refraction, that little copy thing you wrote down. Do you see the part that says measured angle toward the bottom, maybe 2 lines up? Then he's pointing at 30, 40, and 60. The next number he comes up with is the tangent of 60. I believe it's in radians, not even degrees. You take that and multiply it by 3958, and you come up with that number. I did it 3 times. So he's making an error. He's making a huge error.
Show that. And then here's another thing. You just said a tangent in radians?
I believe so.
Okay, now look here. Okay, hey, is there a tangent on a flat surface?
Tangent on a flat surface. You have to have a triangle.
Or would it be called a height? Would it be called a height, Cade?
It doesn't matter.
Would it be called a height or a tangent on a flat plane?
What are you talking about? Tangent is a ratio.
Radians is a ratio, you dipshit. Oh my God.
Look, well, in any case, I mean, dude, I mean, the numbers doing the thing.
We haven't even gotten to the second part of it. I'm just trying to figure out the first number. Then, after he figures out the tangent, he makes some sort of wild-ass correction, and the value is
No, I don't, dude. No, I don't. Here's all I do. All I do is as simple as this. I measure 30 degrees, okay? I fucking triangulate 30 degrees. I get 68.55, okay?
Oh.
So 68, okay? So you're talking about no already. So I divide. Listen, I listen. Well, you're not telling me what I do. You can't say no what I do. You can let me finish and say I'm right or wrong. But you can at least let me finish, okay? So I take and I divide 60 by 90 times 68.55 times 0.60. I then subtract that product from 68.55, and that is your true distance. It's that simple, and it's spot on, whether you like it or not, Cade.
He's doing it in degrees after all. He's not doing it. But you're still using a 10. Why are you making that correction? You shouldn't have to make that correction. Why is that?
It's the refracted value. It's the refracted value.
But if the Earth was
That's
flat,
correct.
it should be See, the problem is you're making a correction to come up with some sort of distance, even their distance still. Oh man, you don't. This is so.
So now you can't come up with nothing. Now you're just crying to the choir. Oh man.
Hold on, let me see. So measured angle, we get 30, 40, 60.
Yeah, that isn't degrees. That's my mistake. I apologize.
Well, real fast. Okay, measured angle. So 30. Is that like?
You apologize now, but next time we talk, you'll be making the same ass claim.
So I mean, I just got a quick question for the measured angles, right? So you got 30 degrees, and you got the 2,285. Then the actual distance, the corrected distance or the true distance is 2,057, right? That measured angle, the 30, is that like relative to like the horizon? Are you like starting at the horizon, then like looking up to the?
Yeah.
Okay.
Relative to the horizon.
Wait, so if that's the case, then right? Then at what angle would Polaris be if you're at the North Pole? Celestial refraction. Yeah, if you're at the North Pole.
If you want to go as far as dip corrections and all that, you could. But there's no point in that. That's just going to give you the same amount, just an extra fucking math. If you want it, I can give it to you.
No. What I'm saying is, okay. So if you're at the North Pole, then would that be 90 degrees or 0 degrees according to the map that you have here? Would that be 90?
That's a good question. So 1 degree is that's why I say 90 minus 1, because I'm going to measure the angle at 1 degree. Okay.
Uh-huh.
And but then I'm going to for the focus of latitude and plotting it on a map. As that's why I say 90 minus a. So 89 degrees. So listen, if you triangulate 1 degree, okay. Okay. Well, look, 1 degree change. A 1 degree change is only 60 nautical miles or 69 miles, right? But we know that 1 degree away from Polaris. I mean, we know that 1 degree latitude is 69 miles, right?
Your formulas don't even work out for that.
Way of converting it. No, it's just putting it for latitude, bro. That's it.
Your formulas don't even work out for that, because
that 1 degree latitude isn't 69 miles away from Polaris, correct, Paid?
Yes.
Okay, so 90 minus a, 90 minus 1 equals 89. So then now we know that 89 degrees latitude is 69 degrees away from Polaris, correct, Paid?
Okay, so but your 30 degrees should be at 2070 at 2057. You should be at 2070. You're off by almost 13 miles. You go to 40 degrees. 40 times 69.
I'm not.
Yes, you are.
You didn't do it right. No, I'm
40
not.
Times 69, 40 times 69 is 2760. You're off by almost 30 miles. You go to 60 degrees.
No, dude, hold on. You're using, so what distance are you using, bro? My model has its own distance, man. It's got a model, I think it's 6170.
Why?
Okay.
That's not what we observe.
How do you know? So you can you could get within 80 degrees doing a 6,000 mile measurement.
Yeah.
And hold on, okay, and well, according to you and your model, the Earth is oblate, so it's going to be different in every spot.
A little bit.
So you do the angle, you're going to still get.
You can ignore the oblateness. The Earth
13 miles.
The Earth is very, very slightly oblate.
Insignificant, bro. It'd be insignificant to the angle.
The oblateness is insignificant because it's like 20 miles out of 3958.
Right. So 20 miles is insignificant in your model, but you're going to use 13 to fuck the shit on my model.
For the oblateness,
13 miles is insignificant over that distance.
No, but
bro.
you don't come up. What I'm saying is, when you do that, you don't come up with. You can, if you're good.
Yes, you do. Check your angle. Check your angle and see what angle you come up with. Go 13. Go. You know what? Go 25 miles different and see what angle you get. You get the same angle, bro.
What happens is your final result is 20 miles off, sir. You can get well within that if you're a decent. I mean that's horrible for a celestial nanofix.
Right, yeah, God.
If you're 20 miles off, you hit the rocks, for fuck's sake.
You could never prove that shit. Okay, no, you're talking about a distance of fucking 4,000 miles, bro. You're not changing your angle with 13 miles, but that's not right anyway. Like I said, my distance is a little bit different.
Why?
It's not a lot. Hold on. It's not way different. It's just a little bit different.
It's like 8 miles per degree different.
Well, hold on.
How do you get that in reality? You're just making this.
Okay.
You're just making this ad hoc to fit your formula.
Well, let me
We talking about ad hoc.
Ad hoc, making your.
No, I'm not. Dude.
Yes, you are.
No, you know what ad hoc is?
Yeah.
Ad hoc is 7/6R. Ad hoc is 7/6R. That's ad hoc, bro.
No, ad hoc is what you're doing, sir. You're cramming your formula into reality. You've changed so far. You've made 3 major assumptions.
I made no assumptions. What are you talking about?
You assume the stars are 3959. You've come up.
No,
with
I'm not, bro. No, I'm not. That's what they triangulate to. I'm not assuming anything.
Yeah,
they could be wherever the fuck they want, bro. I could give you 3 reasons why
but you've just
they
used
wouldn't have
39.
to be there.
You're using 3958, and you're not coming.
Bro, it could be a focal point at 3958. It could be a fucking lens or something. It could be a celestial sphere. There's multiple reasons. Bro, you are the one putting assumptions in my mouth that I'm not making.
You don't understand tangents.
Okay,
and
listen.
You're making a correction. You're making
you
a correction.
Don't understand
and even after your correction,
1 degree,
you still come up with the wrong distance.
Do you understand this, Pate? 1 degree over 60 miles on a flat plane.
Nautical miles.
Gives you a height of 3958.7. Do you understand that? Or 69.1 miles, Pate. 69.1 miles.
It's amazing.
1 degree. Hold on, answer the question. Do you understand that gives you a height of 3958.7? Do you understand that?
Say it gives you a height.
Do you understand that triangulates to 3958.7? So if you can't acknowledge that, bro, you're not being honest, bro. You're not being honest.
Because that's the radius of the Earth. We've measured that.
No, that's what we triangulate 1 degree on the ground.
Because
you assume radius. You're putting assumptions in my mouth. You're the one making assumptions.
We
applying that down to the center of a ball that you have in your mind.
Measure it, sir.
If you measured it, you'd measure on top of the ground, okay? Not underneath the ground, okay? That is what I call an assumption. When you start applying shit under your feet, on top of the ground, if you travel 69 miles, okay, and you get a 1 degree change, and you triangulate that on a flat plane, you get 3958.7. Do you understand that?
If
you don't understand that, do you?
Not
but do you understand that's okay? So do you understand that's the triangulated height?
So is the
on a flat plane? Okay.
Is the sun also at 3959? And the moon?
Now let's see if you could scratch up some honesty.
Is the sun also at 3958?
Don't change the subject. Do you understand? Do you understand?
Well, you have to explain the Artosius experiment now.
See, so I'm exposing this guy's honesty right here, y'all. He won't acknowledge the fact that their radius comes from empirical observation above ground.
That's one of the ways to measure the radius. There are others, like the Artosius experiment, the Al-Biruni experiment.
That's not measuring the radius, bro. Yes, that is on top of the ground using a flat surface. Bro, that's not a curved surface. You get a whole different answer using a curved surface. That is flat, plain fucking trigonometry.
You don't have to make your ad hoc
correction. It is, bro. I promise on my life that triangulates with a flat baseline. 69.1 miles triangulates out to a height of 3958.7. Okay, that is not a radius of Earth. That's where they got the radius.
To the stars, you trilaterate your position, sir. It's the intersection of circles.
So why are you trying to pin me down? Triangulate.
Because you are wrong.
You don't triangulate. Huh? No, I'm asking you a question.
Wrong. You are triangulating.
Why are you questioning any model
triangulating,
if
sir.
your model doesn't use triangulation, huh? Answer the question,
bro.
You
are triangulating, sir. I am not. I am trilateralating.
Why? Why aren't you triangulating?
Because you don't triangulate. All you're doing is measuring angles and figuring out your position to the star. You're drawing circles and the intersection of the circles.
You know why you can't triangulate? Because it doesn't work on a globe. That's why.
You're correct. Triangulation does not work on a globe because you don't. That's why
So
you
quit
don't
trying to pinpoint that shit on a flat Earth.
You
Don't ever bring up triangulation on a flat Earth
Hold on
again.
a second. You, sir, by these formulas, you are triangulating. You have a height to the stars that you cannot confirm, that you conflate from the radius of the Earth. You then take
Once
the
again,
tangent.
bro.
You then take the
Once
tangent,
again.
and then you make some sort of bullshit correction, and you still come up with the wrong distance.
No, what? No, I don't. And
Yes,
once
you
again,
do.
you're making assumptions for me, and I don't appreciate it.
Well,
I'm
no,
not
your
making
math
any
is
assumptions,
wrong.
bro.
At
All I'm
60
doing
degrees.
is measuring.
Listen
Let me
to me.
finish. All I'm doing, once again, for anybody who's actually listening, I measure an angle, I triangulate the fucking distance, and apply my equation. No assumptions at
How do you
all.
get that equation? How do you get that equation? How do you know the stars are 3959? What's the correction?
I don't.
Why is there
I
a
don't.
correction?
Once again,
Why are you
I
still
don't.
off
Nobody
by 20,
knows.
Why are you still off by
He
20
goes right to fucking putting an assumption in my mouth. I don't care how high they are.
You don't? Well, you need 3959 in order for it to fucking work.
That's what it measures to, you fucking idiot.
No, it doesn't.
For last
It's the
time.
radius of the Earth.
No, it's not.
Yes, it is. We've measured it at least 3 different ways.
That's your assumption, dude.
No,
You
it's
are
not an
projecting your
assumption,
assumptions onto me.
No, there's not an assumption. This is measured.
You
at least
are a liar,
3
bro.
different ways.
Everybody, dude, there are Glovers who will admit that it is fucking assumed. Professor Phil Bell
No, it is
is
not
one of them, bro.
assumed.
Dude, it's what we get. 1 degree, 69 miles, bro, on top of a flat surface.
That is one way
if
to
you
measure
triangulate it, if you use a flat baseline triangle, you get 3958.7. Bro,
it's not flat.
I know
though,
you don't
sir.
like it. I know you don't like it, bro.
Not
But
only
it's
that,
what
but
the trigonometry dictates, bro.
Okay, so you're saying that 1 degree is what, 69 miles? So let's see, it's 60 degrees. What's 60 times 69? Do 60 times 69. 60.
About 4155. Wow.
Equals 4140 is what I get.
Wait, hold on, wait. How'd you get that? Did you triangulate? No, how did you get that? Hey, how did you come up with that on a globe?
You just, because we've measured it. 1 degree, 69 miles.
Yeah, exactly. It's fucking empirical.
Exactly.
It doesn't matter what model it is. That's what we fucking measure.
So what is 69
No,
times?
I want to know how you got that distance, though.
You measured it.
What are you triangulating to?
It's Polaris in this case. So it's 60 times 69.
So you measured it in reality, and that's what angle you got.
So it's 60 times 69, sir.
So I rest my case, bro.
What is 60 times 69?
I already told you, but you just said how they get it. They measure it. They don't triangulate on a sphere.
What is 60 times 69, sir?
Bro, you're fucking absurd distances.
What is 60 times 69?
I already told you, bro. It's like 41 something. Who cares?
4140.
That's reality. That's not on a globe.
Your final distance is 4143. You're off by almost 30 miles. You would run into rocks if you did
You're
that.
so full of shit. That's because you don't understand my formula.
This is you, sir.
If you did it right, you get the right answer, bro.
This is your formula, sir, not me. At the bottom angle, measured angle, 30. This
Bro,
is 68.
why don't you come up with a legitimate argument instead of flawing my numbers, bro?
This is your
Why don't you look
numbers.
at my entire fucking model?
This is your
look at my entire model, bro. Bro, hold on, dude. Look at my entire model, and then fucking tell me where I'm wrong.
I'm reading
Come
off
up with a legitimate argument, bro.
I'm reading
Come up
your
with a fucking legitimate argument. Don't just misscrew my model, bro.
I'm reading your numbers.
Fuck that, dude. I worked hard on that fucking model, dude.
I am reading
your stupid ass
numbers
fucking
off of your
doing it wrong.
formula, and you're telling me I'm wrong. How can I be wrong?
You're a fat lying sack of shit, bro. You are dead wrong, bro.
You moron.
You're dead fucking wrong, dude.
Dumb shit. This is your numbers off of your piece of paper. How can I be wrong when they're your fucking numbers?
You're not using the entire model. I already told you the fucking
distances. This is your numbers. You presented this fact as yours, not mine. I am reading your numbers off of your formula, and you're telling me I'm wrong.
Dude, you did it wrong, bro. Once again, you did it wrong.
Your fucking numbers, sir, not mine.
Bro, it's on my fucking video, and it's fucking right. Unfortunately, you do it wrong. Just because you did it wrong don't mean my shit's wrong.
You're not right. Measured angle, 60
bro,
degrees.
I can't hold your hand and do the math with
minus 2742 miles equals 4113. You're 30-some miles off.
Dude, you're a fucking lying sack of shit, dude.
You said that 60 miles.
You did it fucking wrong once again, bro. Once again.
This is your fucking numbers.
Every time you get, dude, it's fucking spot on. You're full of shit, dude.
No, what is 60 times 69, sir? You said for every 1 degree, it's 69 miles. 69 times 60 is what?
That's empirical. That is fucking empirical, right?
So
That's
what's your calculations?
Dude, he keeps dodging the point, bro. He keeps dodging the point.
I'm
That's
not
with a
dodging the
flat
point.
baseline, right?
Your fucking
Hold
numbers.
on, that's with a flat baseline, correct?
Oh my fucking God. I'm reading your numbers
Dude,
off of your piece of paper, and you're telling me I'm wrong.
Dude, you're dead fucking wrong.
How am I dead fucking wrong?
Because it's not 30 miles off. That makes you a lying
It is
sack of
too.
fucking
You
shit,
said that
dude.
every degree
You're a lying
is
sack of shit, dude. You
Up
are
here.
a lying sack of fucking shit.
69.1 miles. 69.1 miles per degree.
I gotta go, dude. I gotta go. This guy's a lying sack of shit. So they're telling me right through his teeth that I'm off 30
I'm
miles,
reading
bro.
your fucking numbers, you moron.
Dude, my numbers don't say I'm 30 fucking degrees off, you fucking
That's
idiot.
because you
Or
haven't
30
figured
miles
it out.
off.
So wait a minute.
You're
Hold
a
on.
lying sack of fucking shit, dude.
Is every degree 69 miles? Yes or no?
No.
Why not?
What do you mean, why not? That's what the fuck 1 degree is, right?
Every degree is 69 miles. That's correct.
Okay, my distance is 6170.
How do you figure that? How do you figure that?
Because go 69 miles and get a 1 degree difference. Go 68.5
right here,
and you
have
still
80
get a 1 degree
degrees.
difference.
So
Bro, I'm not gonna coach you through all this shit, dude.
You say
you're
up
sitting
here,
there
right
fucking
here.
misinterpreting my
B
fucking
equals
model.
69.1. At 1 degree, it's 69 miles. So at 60 degrees, it's not 69 miles.
Hold on. So 3958 is that that's just to 69 miles paid? Paid. Try 68.5 and see what you get paid. See if you get 37 or 3957.8. I mean 0.6 paid.
These are your numbers.
If you're gonna use my model, use it fucking correctly. You lying sack of fucking shit.
You're changing the model now, huh?
No, 3958, correct? It still fucking averages out to 3958. Does it not paid? Fucking sick of this fucking piece of shit, dude. I gotta go.
For fuck's sake.
I'm not following. I wish I could see all this written
The
out.
reason I said 3958.7, that's not in my model. That is me telling him. I don't use 3958.7 in my fucking equation.
What do you use?
The reason I told him that is because that's exactly the Earth's radius. And in the globe model, 69.1 miles is what they use. Not in my model. That is to show you where you got your radius from, bro. That's it. Mine is a little bit less, slightly less. Not much, but a little bit less because that's my model.
Oh, so it's because that hoc fits your model?
Why 7/6R paid? Why?
I'm not talking about 706R. We're talking about the altitude to Polaris in your model. It's not 3959. You kept on saying it's 3959. Now it's not?
No, it's 3958. 3950 fucking 8.
Oh, 3958.7.
It's actually, that's rounded up. That's rounded up too.
Oh, excuse me. 3958.7. Excuse
me. Dude, y'all, I can't talk no more, but please don't let this fucking piece of shit lie on me while I'm gone, please.
For fuck's sake. I'm using your fucking numbers from your fucking thing, and you say I'm wrong.
You both sound really stupid.
You even got the distance to the equator wrong. Hope I save this thing. Save this piece of shit.
Maybe not.
So is this formula that Brian is presenting something to do with the sextant, or
Yes, you
does it
think so?
have?
He's even got he's even got the pole to equator distance wrong. He thinks this is how he thinks sections work on a flat plane. I saved it.
So I'm not. I'm confused. I mean, does the procedure that's actually recorded and written and the way it's being done and working, what's wrong with that?
He doesn't understand it. I mean, the normal procedures that everyone uses except for Brian?
Yeah.
Yeah, because you have to go into the almanac. Based on 6170 miles.
You got to go in an almanac page. You know exactly the distance, right? Look at the angle.
Your distance to the pole of the equator is off too.
Why do you need an almanac if you know exactly the distance?
You
Just
don't
curious.
know. That's what you're trying to figure out is the distance. You're trying to
You
figure
just
out.
said you know the distance. You just said it's exactly fucking such and such miles per degree.
From what? Yeah, 69 miles per degree, exactly.
Okay, so why do you need an almanac if you already know the distance?
Because it only works. What you're doing right now is the ground position for Polaris stays basically in the same spot. It's not exact, but it's close enough to the North Pole. If you'd use any of the 57 other stars, you have to have the time that you are so that you know the ground position because that ground position is moving. So you take the time when you shot the star and you go into the almanac with those numbers. That's why you have to have a watch.
All you really got to know is where that star sits above, right? You just got to know the zenith to the star.
Yes.
Okay, now how is that? How is that fucking conclusive to a globe, bro? That's reality. That doesn't. You're not triangulating shit on a globe. That's reality, bro. No matter what shape the Earth is, that's reality.
Yeah, but you figure your angle from your zenith, and then you multiply that angle by 60 nautical or 69 miles to get the length of that line that is from the GP to your position on that.
Howard, why would you need all that? All you need to do is go into Almanac and see where that star sits overhead, and then apply your distances. That's all you'd need, bro. If it was
you got to calculate. No, that gives you the GP, but it doesn't tell you how far away you are from that GP. You have to have the angle.
You just need like I said, if it was just if you just use a globe, then you could have a globe with you, and just look in and find out where 3 stars are, where they sit above, where they're directly overhead, and you automatically know the distances, right? Because you have the degrees. So you measure the angle and check out the zenith, and you know exactly how far. You know exactly where you're at with 3 measurements.
Correct.
Okay.
You have to draw 3 circles around those three ground positions. The intersection of those 3 circles is your position.
Okay. Why would you need the horizon? Why would you need dip corrections? Why would you need tangents or any of that shit?
You don't need tangents. You need tangents on the flat Earth. What you need in the globe, you measure the position on a nautical sextant. You measure to the
is there a tangent on a flat plane? Is there a tangent? Do you know what a tangent is, bro?
Yes. Do you?
You know what a tangent is? A tangent is a straight line that meets at a single point. That meets at a single point on a circle or a sphere.
There's also
Okay. So is there a tangent to a flat plane, Paige?
Hold on a second. When we say tangent in
No, because all you understand is your globe, bro. You don't understand. You don't understand math and reality, bro. You just understand your spiritual bullshit.
When we say tangent, and we're talking about trigonometry, we are talking about a function that is the opposite over the adjacent. In your thing, a over b. That number is called the tangent.
But we don't have the adjacent, do we? We're trying to figure out the adjacent, aren't we?
Exactly.
Aren't we, Paige?
Exactly. On the flat Earth.
So we're not using the tangent.
Listen to me again. Now, knowing that the opposite over the adjacent equals a tangent, you can figure out the distance you want to know, b, by dividing a by the tangent. That'll equal
I also can figure out, I also can figure it out by fucking dividing the fucking opposite over the sine.
We don't know the hypotenuse.
He just walked you through it, bro. He showed you the other way of doing it. But either way, dude. Either way.
Use the sine and then
either
use
way,
the cosine.
You still didn't answer
what?
the question. Though.
Guess what?
Is there a tangent on a flat plane? You know?
Oh,
would it hurt you to just answer simple questions honestly?
You don't understand trigonometry.
Bro, you've demonstrated. You're projecting onto me, dude. All you can say is I don't understand. You can't answer my simple fucking question.
Look up the definition
all you can keep
of
doing
tangent.
is saying I don't understand. So I ask you a question, and the answer is you don't understand.
Because
dude,
you don't.
That's why I call you a lying sack of shit, bro. You can't
Look
answer
up
an
the
honest,
definition.
simple question.
Right now.
You have to tell me I don't understand.
Stop yelling at me for a second. Sit down on your fucking computer. Type in trigonometry, tangent, definition, and see what you get.
I understand the tangent function.
No,
I understand the arctangent function, bro. That's not the only way it works, bro. For the last time, for the love of God, that's not the only way it works.
Well, if you wanted to take the sine divided by the cosine, guess what? You end up with a tangent. For fuck's sake, you're doing more
no matter
work
what
that
I tell
way.
him, even his own guy showed him on paper.
Showed him,
and he still denied it, bro. He apologized earlier. He even apologized for being wrong, and now he's right back. I told you he'd be right back to fucking line.
He did a couple calculations incorrectly. Big deal. What you're doing now, sir.
Bro, he showed you how to figure out the adjacent without using a tangent, and you apologized. And now you're right back to fucking line.
What he did is he took this sine divided by the cosine, I think it was. And guess what that equals? The tangent.
No, that's not what he did, bro. That's not what he fucking did, bro. You don't understand, bro. You really do not understand.
Oh my God, no, you're right. I don't understand how you fucked this up. I'm working on it.
I promise you don't understand, bro. Because
first of all, you've got 3959 to the stars, which is the radius of the Earth. Your 6,170 polar equator is wrong. It's actually 6,210.
I can't go back to doing what I'm doing, dude, because he's gonna fucking start lying on me as soon as I fucking
correction, and you're still
nobody
off
will
by 30
defend
miles.
me. No, it's not 30 fucking miles, you lying fucking sack
you are
of
off
shit,
by
dude.
30 fucking miles. What
It's not off by 30 miles, you lying sack of shit. I already
60
explained it.
69,
And as soon as
sir.
I go on mute, he's going to start fucking lying on me some more,
What is
and nobody
60
will defend me.
69, sir?
Ryan,
you're not applying my
point,
model correctly,
Ryan,
bro. Just because you do not
These are
understand
your
my
numbers.
model.
These are your fucking numbers, not mine, moron.
At this point, you're just making yourself sound as stupid as he's being.
I don't care, dude. I worked my ass off on this model, and I got this fat lying sack of shit applying it wrong. He's applying it wrong every time I go on mute.
I'm not
to do
applying
what
it wrong.
supposed
I'm
to be
using your fucking numbers.
This piece of shit starts fucking lying.
Maybe not.
Hello, moron. I'm using your numbers, not my numbers.
But you're not applying the whole fucking model, are you?
It's spiraling out of control.
For fuck's sake.
It's a fat lying sack of shit, dude.
I'm using your numbers,
as soon as
moron.
I fucking go to mute, do what I'm supposed to be doing, he's gonna start lying. Next thing you know, I'll be 50 miles off. I'll be 80 miles off.
Sweet. Did it go quiet or is it me? Everybody's still there?